1. Introduction to Programming. 1.1 Understanding Programming Concepts. To become a better programmer, it is essential to have a solid understanding of programming concepts. These concepts form the foundation of your programming knowledge and skills. In this section, we will explore some of the fundamental concepts that every programmer should know. Variables and data types. Variables are used to store and manipulate data in a program. They act as containers that hold values, which can be of different types. Understanding data types is crucial because it determines the kind of operations you can perform on the data. Common data types include integer, used to store whole numbers; float, used to store decimal numbers; string, used to store text; boolean, used to store true or false values; array, used to store a collection of values of the same type; object, used to store a collection of related data and functions. By understanding variables and data types, you can effectively manage and manipulate data in your programs. Control flow and loops. Control flow refers to the order in which statements are executed in a program. It allows you to control the flow of execution based on certain conditions. Conditional statements, such as if-else and switch statements, enable you to make decisions and execute different blocks of code based on those decisions. Loops are used to repeat a block of code multiple times. They are essential for automating repetitive tasks and iterating over collections of data. Common types of loops include the for loop, while loop, and do-while loop. Understanding control flow and loops is crucial for creating programs that can make decisions and perform repetitive tasks efficiently. Functions and methods. Functions and methods are blocks of reusable code that perform a specific task. They allow you to break down complex problems into smaller, manageable parts. Functions take input parameters, perform operations, and return a result. In procedural programming, functions are standalone blocks of code. In object-oriented programming, methods are functions that are associated with a specific object or class. By using functions and methods, you can write modular and reusable code, making your programs more organized and easier to maintain. Arrays and collections. Arrays and collections are used to store multiple values in a single variable. They provide a way to group related data together. Arrays are fixed in size, while collections, such as lists and dictionaries, can dynamically grow or shrink. Arrays and collections are essential for working with large sets of data, such as lists of names or records. They allow you to perform operations on the entire set of data or access individual elements within the collection. Understanding arrays and collections is crucial for efficient data manipulation and storage in your programs. These are just a few of the fundamental programming concepts that every programmer should understand. By mastering these concepts, you will have a solid foundation to build upon as you continue to learn and grow as a programmer. In the next section, we will explore how to choose the right programming language for your projects. 1.2 Choosing the right programming language. Choosing the right programming language is a crucial decision for any programmer. The programming language you choose will determine the tools, libraries, and frameworks available to you, as well as the types of projects you can work on. In this section, we will discuss some important factors to consider when choosing a programming language and provide guidance on how to make an informed decision. Factors to consider. 1. Project requirements. The first and most important factor to consider when choosing a programming language is the specific requirements of your project. Different programming languages excel in different areas, so it's essential to understand what your project needs. For example, if you're developing a web application, languages like JavaScript, Python, or Ruby may be suitable. On the other hand, if you're building a mobile app, you might consider languages like Swift or Kotlin. 2. Learning curve. Consider your familiarity with programming languages and your willingness to learn new ones. If you're a beginner, it might be wise to start with a language that has a gentle learning curve and a supportive community. Languages like Python or JavaScript are often recommended for beginners due to their simplicity and extensive documentation. However, if you're an experienced programmer looking to expand your skill set, learning a more complex language like C++ or Java might be a good challenge. 3. Community and support. The programming language you choose should have an active and supportive community. A strong community means you'll have access to a wealth of resources, including forums, tutorials, and libraries. It also means that if you encounter any issues or bugs, there will be a community of developers ready to help you. Popular languages like Python, JavaScript, and Java have large and vibrant communities, making them excellent choices for many projects. 4. Performance requirements. Consider the performance requirements of your project. Some programming languages are known for their speed and efficiency, while others prioritize ease of use and readability. If you're working on a project that requires high-performance computing, languages like C or C++ might be the best choice. However, if your project doesn't have strict performance requirements, you might prioritize a language that allows for faster development and easier maintenance. 5. Ecosystem and libraries. The availability of libraries and frameworks can significantly impact your productivity as a programmer. A robust ecosystem with a wide range of libraries can save you time and effort by providing pre-built solutions for common tasks. Before choosing a programming language, research the availability and quality of libraries and frameworks in that language. For example, if you're interested in data analysis and machine learning, Python's ecosystem with libraries like NumPy, Pandas, and TensorFlow might be a great fit. 6. Job market. Consider the job market and career opportunities associated with different programming languages. Some languages are more in demand than others, and having expertise in a popular language can open up more job opportunities. Research the job market in your area and identify the languages that are in high demand. However, keep in mind that the job market is constantly evolving, and it's essential to balance market demand with your personal interests and goals. Making an informed decision. To make an informed decision when choosing a programming language, it's crucial to gather as much information as possible. Here are some steps you can take. Research. Read articles, books, and online resources to understand the strengths and weaknesses of different programming languages. Look for comparisons and case studies that relate to your project requirements. Experiment. Try out different programming languages by building small projects or completing coding exercises. This hands-on experience will give you a better understanding of the syntax, features, and development process of each language. Seek advice. Reach out to experienced programmers or join online communities to seek advice and gather insights. Discuss your project requirements and goals with others who have experience in the programming languages you're considering. Consider future growth. Think about your long-term goals and the potential for future growth. Will the programming language you choose allow you to expand your skills and work on a variety of projects? Consider the language's versatility and its relevance in the industry. Remember, there is no one-size-fits-all answer when it comes to choosing a programming language. The right choice depends on your project requirements, personal preferences, and long-term goals. By considering the factors mentioned above and conducting thorough research, you can make an informed decision that sets you up for success as a programmer. 1.3 Setting up your development environment. Setting up a proper development environment is crucial for becoming a better programmer. A well-configured environment can greatly enhance your productivity and efficiency. In this section, we will discuss the key components and steps involved in setting up an effective development environment. Choosing an integrated development environment (IDE). An integrated development environment (IDE) is a software application that provides comprehensive tools and features to facilitate software development. Choosing the right IDE is essential as it can significantly impact your coding experience. Here are a few popular IDEs to consider. Visual Studio Code. Visual Studio Code is a lightweight and highly customizable IDE developed by Microsoft. It supports a wide range of programming languages and offers a rich set of extensions to enhance functionality. Eclipse. Eclipse is a widely used IDE, particularly for Java development. It provides a robust set of tools and features, including code completion, debugging, and version control integration. IntelliJ IDEA. IntelliJ IDEA is a powerful IDE primarily designed for Java development. It offers advanced code analysis, refactoring tools, and seamless integration with build systems like Maven and Gradle. PyCharm. PyCharm is a popular IDE for Python development. It provides intelligent code completion, debugging capabilities, and support for various frameworks like Django and Flask. Choose an IDE that aligns with your programming language and personal preferences. Experiment with different IDEs to find the one that suits your needs best. Installing the required software. Once you have chosen an IDE, you need to install the necessary software components to support your programming language and development environment. Here are some common components you may need to install. Programming language. Install the latest version of the programming language you will be working with. Most programming languages have official websites where you can download and install the language-specific compilers or interpreters. Build tools. Depending on your project requirements, you may need to install build tools like Maven, Gradle, or NPM. These tools automate the build process and manage dependencies. Version control system. Install a version control system like Git to track changes in your codebase and collaborate with other developers effectively. Git provides command line tools, but you can also install graphical user interfaces, GUIs, like SourceTree or GitKraken for a more visual representation. Database management system. If your project involves database interactions, install a database management system, DBMS, like MySQL, PostgreSQL, or MongoDB. These systems allow you to create and manage databases, execute queries, and test your application's data-related functionality. Additional libraries and frameworks. Depending on your project requirements, you may need to install additional libraries or frameworks. These can be installed using package managers specific to your programming language, such as pip for Python or npm for JavaScript. Ensure that you follow the installation instructions provided by the respective software vendors to set up each component correctly. Configuring your IDE. After installing the necessary software, you need to configure your IDE to optimize your workflow. Here are some essential configurations to consider. Theme and color scheme. Choose a theme and color scheme that is visually appealing and comfortable for long coding sessions. Many IDEs offer a variety of themes, including light and dark options. Font and font size. Select a font and font size that is easy to read. Consistency in font choice across your projects can also improve code readability. Code formatting. Configure your IDE to automatically format your code according to your preferred coding style. Consistent code formatting enhances readability and makes collaboration with other developers easier. Code completion and IntelliSense. Enable code completion and IntelliSense features in your IDE. These features provide suggestions and auto-completion for code snippets, function names, and variable declarations, saving you time and reducing errors. Keyboard shortcuts. Familiarize yourself with the keyboard shortcuts provided by your IDE. Learning and utilizing keyboard shortcuts can significantly speed up your coding process. Plugins and extensions. Explore the available plugins and extensions for your IDE. These can enhance your productivity by providing additional features, such as code linting, debugging tools, and integration with external services. Take the time to explore the various settings and options in your IDE to customize it according to your preferences and workflow. Creating a project structure. Organizing your project structure is essential for maintaining a clean and manageable codebase. Consider the following guidelines when creating your project structure. Separation of concerns. Divide your code into logical modules or components based on their functionality. This separation allows for easier maintenance and promotes code reusability. Naming conventions. Follow consistent naming conventions for files, folders, and variables. Clear and descriptive names make it easier for you and other developers to understand the purpose of each component. Version control integration. Initialize your project as a Git repository and create an initial commit. This allows you to track changes and collaborate with other developers effectively. Documentation. Include a README file in your project's root directory to provide an overview of the project, installation instructions, and any other relevant information. By establishing a well-organized project structure, you can easily navigate and manage your codebase, leading to better code quality and maintainability. Conclusion. Setting up your development environment correctly is a crucial step towards becoming a better programmer. By choosing the right IDE, installing the necessary software components, configuring your IDE to suit your preferences, and organizing your project structure effectively, you can create an environment that enhances your productivity and enables you to write clean and efficient code. Invest time in setting up your development environment properly, as it will pay off in the long run by improving your coding experience and overall programming skills. 1.4 Learning resources for programmers. As a programmer, it is essential to continuously learn and improve your skills to stay up to date with the latest technologies and programming languages. Fortunately, there are numerous learning resources available that can help you enhance your programming abilities. In this section, we will explore some of the most valuable learning resources for programmers. Online tutorials and courses. One of the most popular ways to learn programming is through online tutorials and courses. Websites like Coursera, Udemy, and Codecademy offer a wide range of programming courses taught by industry experts. These courses cover various programming languages, frameworks, and concepts, allowing you to learn at your own pace. Additionally, many of these platforms provide interactive coding exercises and projects to help you apply what you've learned. Documentation and official guides. When working with a specific programming language or framework, it is crucial to refer to the official documentation and guides. These resources provide in-depth explanations of the language syntax, libraries, and APIs. They often include code examples and tutorials to help you understand how to use different features effectively. By familiarizing yourself with the official documentation, you can gain a deeper understanding of the programming language and leverage its full potential. Online coding communities. Engaging with online coding communities can be an excellent way to learn from experienced programmers and get feedback on your code. Websites like Stack Overflow, GitHub, and Reddit have active communities where programmers can ask questions, share knowledge, and collaborate on projects. By participating in these communities, you can gain insights into best practices, discover new programming techniques, and receive guidance from experts in the field. Programming books. Books are a timeless resource for learning programming. They provide comprehensive explanations and examples that can help you grasp complex concepts. Whether you prefer physical books or ebooks, there is a vast selection of programming books available on various topics. Some popular programming books include Clean Code, by Robert C. Martin, The Pragmatic Programmer, by Andrew Hunt and David Thomas, and Introduction to Algorithms, by Thomas H. Corman et al. These books cover fundamental programming principles, best practices, and algorithmic problem-solving techniques. Online coding challenges and platforms. Participating in coding challenges and using online coding platforms can significantly improve your programming skills. Websites like LeetCode, HackerRank, and CodeAwars offer a wide range of coding challenges that test your problem-solving abilities. These challenges often require you to write efficient code and optimize algorithms. By solving these problems, you can enhance your logical thinking, algorithmic skills, and ability to write clean and efficient code. Open source projects. Contributing to open source projects is an excellent way to gain practical experience and collaborate with other programmers. Open source projects allow you to work on real-world applications and learn from experienced developers. By contributing to these projects, you can improve your coding skills, gain exposure to different programming techniques, and build a portfolio of your work. Websites like GitHub provide a platform for discovering and contributing to open source projects. Online video tutorials and webinars. Video tutorials and webinars are another valuable resource for learning programming. Platforms like YouTube and Vimeo host a vast collection of programming tutorials and webinars on various topics. These videos often provide step-by-step instructions, demonstrations, and explanations of programming concepts. Additionally, many programming communities and organizations host webinars where industry experts share their knowledge and insights on specific programming topics. Blogs and technical websites. Blogs and technical websites are a great source of programming knowledge and insights. Many experienced programmers and industry experts share their expertise through blog posts and articles. These resources cover a wide range of programming topics, including tutorials, best practices, and industry trends. Subscribing to programming blogs and following technical websites can help you stay updated with the latest advancements in the field and gain valuable insights from experienced professionals. Online forums and discussion boards. Online forums and discussion boards provide a platform for programmers to ask questions, seek advice, and engage in discussions. Websites like Reddit, Quora, and Stack Exchange have dedicated programming communities where you can find answers to your programming queries and learn from the experiences of others. Participating in these forums allows you to expand your knowledge, gain different perspectives, and connect with fellow programmers. Podcasts and audio resources. If you prefer audio-based learning, podcasts and audio resources can be a valuable addition to your learning journey. There are several programming podcasts available that cover a wide range of topics, including interviews with industry experts, discussions on programming trends, and tips for improving your coding skills. Listening to these podcasts can help you stay informed about the latest developments in the programming world and gain insights from experienced professionals. In conclusion, there are numerous learning resources available for programmers to enhance their skills and stay updated with the ever-evolving field of programming. Whether you prefer online tutorials, books, coding challenges, or engaging with coding communities, the key is to have a growth mindset and continuously seek opportunities to learn and improve. By leveraging these resources effectively, you can become a better programmer and stay ahead in your programming career. Learning resources for programmers 2. Mastering the fundamentals. 2.1 Variables and data types. In programming, variables are used to store and manipulate data. They act as containers that hold values, which can be of different types. Understanding variables and data types is fundamental to becoming a better programmer. In this section, we will explore the concept of variables, the different data types available, and how to work with them effectively. Variables. A variable is a named storage location in a computer's memory that can hold a value. It allows us to store and manipulate data during the execution of a program. Before using a variable, we need to declare it by specifying its name and data type. For example, hash variable declaration and initialization age equals 25. Name equals John Doe. In the above example, we declared two variables, age and name. The variable age is assigned an integer value of 25, while the variable name is assigned a string value of John Doe. It's important to note that variables can change their values throughout the program's execution. Data types. Programming languages provide various data types to represent different kinds of values. The choice of data type depends on the nature of the data we want to store. Here are some commonly used data types. 1. Integer. The integer data type represents whole numbers without any fractional or decimal part. In most programming languages, integers can be positive or negative. For example, int age equals 25, 2. Floating point. Floating point data types are used to represent numbers with a fractional or decimal part. They can store both small and large numbers. For example, float pi equals 3.14, 3. String. The string data type is used to represent a sequence of characters. It is commonly used to store text or any combination of letters, numbers, and symbols. For example, var name equals John Doe, 4. Boolean. The Boolean data type represents a logical value, which can be either true or false. It is often used in conditional statements and logical operations. For example, bool is student equals true, 5. Array. An array is a data structure that can store a fixed size sequence of elements of the same type. It allows us to group related data together. For example, int numbers equals 1, 2, 3, 4, 5, 6. Object. The object data type is a more complex type that can store multiple values and methods. It is used to represent real-world entities or concepts. For example, class person. Def underscore underscore init underscore underscore self, name, aged self.name equals name self.age equals age. Person equals person, John Doe, 25. These are just a few examples of commonly used data types. Different programming languages may have additional data types or variations of these types. Type inference. Some programming languages support type inference, which allows the compiler or interpreter to automatically determine the data type based on the assigned value. This can save us from explicitly declaring the data type. For example, var age equals 25, the variable, age, is inferred as an integer. Type inference can make code more concise and readable, but it's important to be aware of the potential pitfalls. In some cases, it may lead to unexpected behavior or performance issues. Type conversion. In programming, we often need to convert data from one type to another. This can be done explicitly through typecasting or implicitly through automatic type conversion. For example, hash explicit typecasting age equals 25. Age underscore str equals str age hash convert integer to string. Hash implicit type conversion. Result equals 10 plus 3.14 hash. The integer 10 is implicitly converted to a float. It's important to understand the rules and limitations of type conversion in the programming language you are using to avoid unexpected results or errors. Summary. Variables and data types are fundamental concepts in programming. They allow us to store and manipulate data effectively. By understanding the different data types available and how to work with them, we can write more robust and efficient code. In the next section, we will explore control flow and loops, which are essential for controlling the execution of a program. 2.2. Control flow and loops. Control flow and loops are essential concepts in programming that allow you to control the execution of your code and repeat certain actions. By understanding and mastering control flow and loops, you can write more efficient and flexible programs. In this section, we will explore the different control flow statements and loop structures available in most programming languages. Control flow statements. Control flow statements determine the order in which the instructions in your code are executed. They allow you to make decisions and perform different actions based on certain conditions. The most common control flow statements are 1. If-else statements. The if-else statement is used to execute a block of code if a certain condition is true and another block of code if the condition is false. It follows the syntax. If condition. Hash code to be executed if the condition is true else. Hash code to be executed if the condition is false. For example, consider a program that checks if a number is positive or negative. Num equals 10. If num greater than 0. Print the number as positive, else. Print the number as negative. 2. Switch statements. Some programming languages provide a switch statement, which allows you to select one of many code blocks to be executed based on the value of a variable. Each code block is associated with a specific value or range of values. Here's an example in JavaScript. Let day equals Monday. Switch day case, Monday. Console.log, it's the start of the week, break. Case, Friday. Console.log, it's almost the weekend, break. Default. Console.log, it's an ordinary day, break. 3. Ternary operator. The ternary operator is a shorthand way of writing an if-else statement in a single line. It follows the syntax. Variable equals value underscore if underscore true if condition else value underscore if underscore false. For example, let's say we want to assign a message based on whether a person is an adult or not. Age equals 25. Message equals adult if age greater than equals 18 else not an adult, print message. Loop structures. Loop structures allow you to repeat a block of code multiple times. They are useful when you need to perform the same action on a collection of data or when you want to repeat a certain task until a specific condition is met. The most common loop structures are 1. For loop. The for loop is used to iterate over a sequence, such as a list, tuple, or string, or other iterable objects. It follows the syntax. For item in sequence. Hash code to be executed for each item. For example, let's say we want to print each element of a list. Fruits equals apple, banana, orange. For fruit in fruits. Print fruit 2. While loop. The while loop is used to repeat a block of code as long as a certain condition is true. It follows the syntax. While condition. Hash code to be executed while the condition is true. For example, let's say we want to count from 1 to 5 using a while loop. Count equals 1. While count less than equals 5. Print count plus equals 1. 3. Do while loop. Some programming languages provide a do while loop, which is similar to a while loop but guarantees that the code block is executed at least once, even if the condition is initially false. Here's an example in Java. Int count equals 1. Do. System.out. Print ln count plus. While count less than equals 5. Loop control statements. Loop control statements allow you to control the flow of a loop. They provide additional flexibility and control over how the loop behaves. The most common loop control statements are 1. Break statement. The break statement is used to exit a loop prematurely. When encountered, it immediately terminates the loop and continues with the next statement after the loop. Here's an example in C++. For int I equals 1, I less than equals 10, I plus. If I equals 5 break. Q less than I less than endl. 2. Continue statement. The continue statement is used to skip the rest of the code block within a loop and move to the next iteration. It allows you to bypass certain iterations based on a condition. Here's an example in Python. For I in range 1, 6. If I equals 3, continue print I. Conclusion. Control flow and loops are fundamental concepts in programming that allow you to make decisions, repeat actions, and control the flow of your code. By mastering these concepts, you can write more efficient and flexible programs. In this section, we explored various control flow statements, including if-else statements, switch statements, and the ternary operator. We also discussed loop structures such as for loops, while loops, and do-while loops, along with loop control statements like break and continue. Understanding and utilizing these concepts will greatly enhance your programming skills and enable you to solve complex problems effectively. 2.3 Functions and Methods. Functions and methods are essential building blocks in programming. They allow you to break down complex tasks into smaller, more manageable pieces of code. By using functions and methods, you can improve the readability, reusability, and maintainability of your code. In this section, we will explore the fundamentals of functions and methods and discuss best practices for using them effectively. Understanding functions. A function is a block of code that performs a specific task. It takes input, performs operations on that input, and produces an output. Functions are designed to be reusable, meaning they can be called multiple times throughout your program. To define a function, you need to specify its name, input parameters, if any, and the code block that defines its behavior. Here's an example of a simple function in Python that calculates the square of a number. Def square number. Return number asterisk number. In this example, the function is named square, and it takes a single parameter number. The code block inside the function multiplies the number by itself and returns the result. To use the square function, you can call it and pass a value as an argument. Result equals square 5 print result hash output 25. The function call square 5 returns the square of 5, which is then assigned to the variable result. The print statement displays the result, which is 25. Benefits of using functions. Using functions offers several benefits that can help you become a better programmer. Reusability. Functions allow you to encapsulate a specific piece of functionality that can be reused throughout your program. Instead of writing the same code multiple times, you can define a function once and call it whenever needed. This not only saves time but also improves the maintainability of your code. If you need to make a change to the functionality, you only need to modify the function definition, and all the function calls will automatically reflect the update. Readability. Functions make your code more readable by breaking it down into smaller, self-contained units. Each function performs a specific task, which makes it easier to understand the overall logic of your program. By giving meaningful names to your functions, you can also improve the readability of your code. Well-named functions provide a clear indication of what they do, making it easier for other developers, including your future self, to understand and work with your code. Modularity. Functions promote modularity, which is the practice of dividing your code into separate, independent modules. Each function can be seen as a module that performs a specific task. This modular approach allows you to focus on one piece of functionality at a time, making it easier to develop, test, and maintain your code. It also enables collaboration, as different team members can work on different functions simultaneously without interfering with each other's code. Debugging and testing. Functions make debugging and testing easier. Since functions encapsulate specific tasks, you can isolate and test them individually. This allows you to identify and fix issues more efficiently. By writing test cases for your functions, you can ensure that they produce the expected results under different scenarios. This helps catch bugs early on and provides a safety net when making changes to your code. Understanding methods. Methods are similar to functions, but they are associated with objects or classes in object-oriented programming (OOP). In OOP, objects are instances of classes, and methods define the behavior of those objects. Methods are defined within a class and can access and modify the object's data. To define a method, you need to specify its name, input parameters, if any, and the code block that defines its behavior. Here's an example of a simple method in Java that calculates the area of a rectangle. Public class rectangle. Private int length, private int width. Public rectangle int length, int width this. Length equals length, this. Width equals width. Public int calculate area, return length asterisk width. In this example, the rectangle class has a method named calculate area. The method does not take any parameters and returns the area of the rectangle, which is calculated by multiplying its length and width. To use the calculate area method, you need to create an instance of the rectangle class and call the method on that instance. Rectangle equals new rectangle 5, 10 int area equals rectangle. Calculate area system.out. Println area output 50. The new keyword is used to create a new instance of the rectangle class with a length of 5 and a width of 10. The calculate area method is then called on the rectangle object, and the result is assigned to the area variable. The println statement displays the area, which is 50. Conclusion. Functions and methods are powerful tools that can greatly enhance your programming skills. By understanding how to use them effectively, you can write more modular, readable, and maintainable code. Functions allow you to break down complex tasks into smaller, reusable units, while methods enable you to define the behavior of objects in object-oriented programming. Embrace the use of functions and methods in your programming journey, and you will become a better programmer. 2.4 Arrays and collections. In programming, arrays and collections are essential data structures that allow you to store and manipulate multiple values. Understanding how to work with arrays and collections effectively is crucial for becoming a better programmer. This section will introduce you to the concepts of arrays and collections, their differences, and how to use them efficiently in your code. Arrays. An array is a fixed-size data structure that stores a collection of elements of the same type. Each element in an array is assigned a unique index, starting from 0. Arrays provide random access to elements, meaning you can directly access any element by its index. Declaring and initializing arrays. To declare an array, you need to specify the data type of its elements and the size of the array. Here's an example of declaring an array of integers in various programming languages. Int numbers equals new int 5 Java int numbers equals new int 5 C var numbers equals new int 5 C#, using var keyword int numbers equals 1, 2, 3, 4, 5 initializing with values accessing array elements. You can access individual elements of an array using their index. The index starts from 0 and goes up to the size of the array -1. Here's an example of accessing array elements. Int numbers equals 1, 2, 3, 4, 5 int first number equals numbers, 0 accessing the first element int third number equals numbers, 2 accessing the third element modifying array elements. You can modify the value of an array element by assigning a new value to it using its index. Here's an example. Int numbers equals 1, 2, 3, 4, 5 numbers 2 equals 10, modifying the third element to 10 array length. The length of an array represents the number of elements it can store. You can obtain the length of an array using the length property or method provided by the programming language. Here's an example. Int numbers equals 1, 2, 3, 4, 5 int length equals numbers. Length, getting the length of the array. Arrays versus collections. Arrays have a fixed size, and once created, their size cannot be changed. In contrast, collections are dynamic data structures that can grow or shrink in size as needed. Collections provide additional functionality and flexibility compared to arrays. Collections. Collections are data structures that store and manipulate a group of elements. Unlike arrays, collections can dynamically resize themselves to accommodate new elements. Collections also provide various methods and operations for efficient manipulation and retrieval of elements. Types of collections. There are different types of collections available in programming languages, such as lists, sets, and maps. Each type has its own characteristics and use cases. Here are some commonly used collection types. List. A list is an ordered collection that allows duplicate elements. Elements in a list can be accessed by their index. Set. A set is an unordered collection that does not allow duplicate elements. It provides methods for checking membership and performing set operations like union, intersection, and difference. Map. A map is a collection that stores key-value pairs. Each key in a map is unique, and you can retrieve the corresponding value using the key. Declaring and initializing collections. To declare and initialize a collection, you need to import the appropriate library or module provided by the programming language. Here's an example of declaring and initializing a list in various programming languages. Import Java. Util. ArrayList, importing the ArrayList class. ArrayList less than integer greater than numbers equals new ArrayList less than integer greater than Java list less than int greater than numbers equals new list less than int greater than C# list less than int greater than numbers equals new list less than int greater than C++ adding and removing elements. Collections provide methods for adding and removing elements. Here's an example of adding and removing elements from a list. List less than string greater than fruits equals new ArrayList less than string greater than fruits.add apple, adding an element to the list fruits.add banana. Fruits. Remove apple, removing an element from the list accessing and modifying elements. You can access and modify elements in a collection using various methods and operations provided by the programming language. Here's an example of accessing and modifying elements in a list. List less than string greater than fruits equals new ArrayList less than string greater than fruits.add apple. Fruits.add banana. String first fruit equals fruits.get 0 accessing the first element fruits.set 1, orange, modifying the second element collection size. You can obtain the size of a collection using the size method or property provided by the programming language. Here's an example. List less than string greater than fruits equals new ArrayList less than string greater than fruits.add apple. Fruits.add banana. Int size equals fruits, size getting the size of the collection conclusion. Arrays and collections are fundamental data structures that every programmer should be familiar with. Understanding how to declare, initialize, access, and modify elements in arrays and collections is essential for writing efficient and effective code. By mastering the concepts and techniques discussed in this section, you will be well equipped to handle complex data manipulation tasks and become a better programmer. 3. Writing clean and readable code. To become a better programmer, there are several key areas you can focus on improving. These include understanding programming concepts, mastering the fundamentals, writing clean and readable code, understanding algorithms and data structures, efficient problem solving, working with APIs and libraries, version control and collaboration, writing secure code, optimizing performance, continuous learning and improvement, working effectively in a team, and career growth and advancement. In this section, we will explore the importance of naming conventions and code formatting in writing clean and readable code. Good naming conventions and code formatting can greatly enhance the readability and maintainability of your code, making it easier for you and others to understand and work with. Naming conventions. Choosing appropriate and consistent names for variables, functions, classes, and other code elements is crucial for writing clean and readable code. Here are some best practices for naming conventions. Use descriptive names. Choose names that accurately describe the purpose or functionality of the code element. Avoid using single-letter variable names or generic names like temp or data. Be consistent. Maintain consistency in your naming conventions throughout your codebase. If you use camel case e.g., my variable for variables, stick to it consistently. Similarly, if you use Pascal case e.g., my function for functions, continue using it consistently. Follow language conventions. Different programming languages have their own naming conventions. It's important to follow the convention specific to the language you are using. For example, in Python, it is common to use snake case e.g., my underscore variable for variable names. Avoid abbreviations and acronyms. While abbreviations and acronyms may save a few keystrokes, they can make your code less readable. Instead, opt for descriptive names that clearly convey the purpose of the code element. Use meaningful prefixes and suffixes. Adding prefixes or suffixes to names can provide additional context. For example, prefixing Boolean variables with is or has can make their purpose clear, e.g., is ready, has permission. Be mindful of scope. Choose names that reflect the scope and purpose of the code element. For example, if a variable is only used within a specific function, consider using a local variable name that is relevant to that function. Code formatting. Consistent and well-formatted code improves readability and makes it easier to understand the structure and flow of your code. Here are some code formatting best practices. Indentation. Use consistent indentation to visually represent the structure of your code. Most programming languages use either spaces or tabs for indentation. Choose one and stick to it throughout your codebase. Line length. Keep your lines of code within a reasonable length to avoid horizontal scrolling. A common convention is to limit lines to around 80 to 120 characters. Vertical spacing. Use blank lines to separate logical sections of code, such as functions or classes. This helps improve readability and makes it easier to navigate through the code. Consistent braces placement. Choose a consistent style for placing braces, e.g., opening brace on the same line or a new line. Stick to the chosen style throughout your codebase. Commenting. Use comments to explain complex or non-obvious sections of code. Comments should be concise, clear, and provide relevant information without stating the obvious. Code alignment. Align similar code elements vertically to improve readability. For example, aligning assignment operators or method parameters can make the code more visually appealing and easier to understand. Use whitespace effectively. Use whitespace to separate operators, keywords, and other code elements. This helps improve readability and makes it easier to identify different parts of an expression or statement. By following these naming conventions and code formatting best practices, you can significantly improve the readability and maintainability of your code. Clean and readable code is not only easier to understand and work with but also reduces the chances of introducing bugs and makes it easier for others to collaborate on your code. 3.2 Comments and documentation. One of the key aspects of writing clean and readable code is the use of comments and documentation. Comments and documentation play a crucial role in helping other programmers understand your code and its functionality. In this section, we will explore the importance of comments and documentation and provide guidelines on how to effectively use them in your programming projects. The importance of comments. Comments are lines of code that are not executed by the computer but are meant to provide information and explanations to the programmers who read the code. They are used to clarify the purpose, functionality, and logic of the code. Here are some reasons why comments are important. Code understanding. Comments help other programmers, including yourself, understand the code. They provide context and explanations for complex algorithms, logic, or business rules implemented in the code. Code maintenance. Comments make it easier to maintain and update code. When you revisit your code after a long time, comments act as reminders of the code's purpose and functionality, making it easier to make changes without introducing bugs. Collaboration. Comments facilitate collaboration among team members. When working on a project with multiple developers, comments help others understand your code and make it easier for them to contribute or debug the code. Debugging. Comments can be used to temporarily disable or comment out sections of code during the debugging process. This allows you to isolate and identify the source of bugs more effectively. Guidelines for writing effective comments. Writing effective comments requires following certain guidelines to ensure clarity and consistency. Here are some best practices for writing comments. Be clear and concise. Write comments that are easy to understand and concise. Avoid using overly technical jargon or complex language. Use simple and straightforward explanations to convey the purpose and functionality of the code. Use proper grammar and spelling. Maintain proper grammar and spelling in your comments. Poorly written comments can be confusing and may lead to misunderstandings. Comment what, why, and how. When writing comments, focus on explaining what the code does, why it is implemented in a particular way, and how it achieves its purpose. This provides a comprehensive understanding of the code's functionality. Update comments regularly. Keep your comments up to date. If you make changes to the code, ensure that the comments accurately reflect the updated functionality. Outdated comments can be misleading and cause confusion. Avoid redundancy. Avoid commenting on obvious or self-explanatory code. Comments should provide additional information that is not immediately evident from the code itself. Use comment headers. Use comment headers to provide an overview of the code section or function. This helps in quickly understanding the purpose and functionality of the code. Comment troubleshooting steps. If you encounter a specific issue or bug and have implemented a workaround or solution, document it in the comments. This helps other developers who may face similar issues in the future. Documentation. Apart from comments within the code, documentation plays a vital role in providing a comprehensive understanding of a project or codebase. Documentation is typically written separately from the code and provides a high-level overview, usage instructions, and other relevant information. Here are some types of documentation commonly used in programming. Project documentation. Project documentation provides an overview of the entire project, including its purpose, architecture, and key components. It helps new developers onboard quickly and understand the project's structure and functionality. API documentation. If you are developing an API or library, documenting the API endpoints, parameters, and expected responses is crucial. API documentation helps other developers integrate and use your API effectively. Code documentation. Code documentation, also known as inline documentation, involves documenting individual functions, classes, or modules within the code. This documentation explains the purpose, inputs, outputs, and usage of the code. User documentation. User documentation is aimed at end users and provides instructions on how to use a software application. It includes user guides, tutorials, and FAQs to help users navigate and utilize the software effectively. Guidelines for writing effective documentation. Writing effective documentation is as important as writing clean code. Here are some guidelines to follow when writing documentation. Use a consistent format. Maintain a consistent format throughout your documentation. Use headings, subheadings, bullet points, and code snippets to make the documentation easy to read and navigate. Provide examples. Include examples and code snippets to illustrate the usage of functions, classes, or API endpoints. Examples help users understand how to use the code or API effectively. Update documentation. Keep your documentation up to date with the latest changes in the codebase. Outdated documentation can lead to confusion and errors. Include version information. If you are documenting a software application or library, include version information to indicate which version of the software the documentation corresponds to. This helps users understand the relevance and applicability of the documentation. Consider user perspective. When writing user documentation, put yourself in the user's shoes. Anticipate their questions, concerns, and difficulties, and address them in the documentation. Make the documentation user-friendly and accessible to users with varying levels of technical expertise. Provide troubleshooting tips. Include troubleshooting tips and common error messages in your documentation. This helps users resolve issues independently and reduces the need for support. Seek feedback. Encourage users and fellow developers to provide feedback on your documentation. Feedback can help identify areas for improvement and ensure that the documentation meets the needs of its audience. Remember, comments in documentation are not just for others, they also benefit you as a programmer. By investing time in writing clear and comprehensive comments and documentation, you enhance your own understanding of the code and improve your ability to maintain and collaborate on projects effectively. 3.3 Code organization and modularity. One of the key aspects of being a better programmer is writing code that is well organized and modular. Code organization refers to the way you structure your code, while modularity refers to breaking down your code into smaller, reusable components. By following good practices in code organization and modularity, you can improve the readability, maintainability, and reusability of your code. Benefits of code organization and modularity. Code organization and modularity offer several benefits. Readability. Well-organized code is easier to read and understand. When your code is structured in a logical manner, it becomes easier for you and other developers to navigate through the codebase. This makes it simpler to identify and fix bugs, add new features, or make modifications. Maintainability. By breaking down your code into smaller, self-contained modules, you can isolate changes and make updates more easily. This reduces the risk of introducing bugs or unintended side effects. Additionally, modular code allows for easier testing and debugging, as you can focus on individual components rather than the entire codebase. Reusability. Modular code promotes reusability, as you can use the same components in different parts of your application or even in other projects. This saves time and effort, as you don't have to reinvent the wheel every time you need a similar functionality. Reusing code also helps maintain consistency across your projects. Collaboration. Well-organized and modular code facilitates collaboration among team members. When everyone follows the same code organization principles, it becomes easier to understand and work with each other's code. This leads to smoother teamwork and faster development cycles. Principles of code organization and modularity. To achieve effective code organization and modularity, you can follow these principles. 1. Single Responsibility Principle (SRP). The SRP states that a class or module should have only one reason to change. This means that each component should have a single responsibility or purpose. By adhering to this principle, you can keep your code focused and avoid creating large, monolithic classes or functions. Instead, break down your code into smaller, more manageable units that handle specific tasks. 2. Separation of concerns (society). The society principle suggests that different concerns or aspects of your application should be separated into distinct modules or classes. For example, you can separate the user interface logic from the business logic, or the data access code from the application logic. This separation allows for better organization and makes it easier to modify or replace individual components without affecting the entire system. 3. Modular design. Modular design involves breaking down your code into reusable and independent modules. Each module should encapsulate a specific functionality or feature. This allows you to develop and test modules in isolation, making it easier to maintain and reuse them. Additionally, modular design promotes loose coupling between modules, reducing dependencies and making your code more flexible. 4. Naming conventions. Consistent and meaningful naming conventions are essential for code organization. Use descriptive names for variables, functions, classes, and modules to make your code self-explanatory. This helps other developers understand your code and reduces the need for excessive comments. Follow established naming conventions for the programming language or framework you are using to maintain consistency across your codebase. 5. Folder and file structure. Organize your code files and folders in a logical and consistent manner. Create separate directories for different components or modules of your application. For example, you can have separate folders for controllers, models, views, and utilities. This makes it easier to locate and manage specific files. Use meaningful names for folders and files to reflect their purpose or functionality. 6. Documentation. Documenting your code is crucial for understanding its purpose, usage, and dependencies. Use comments to explain the intent of your code, provide usage examples, and document any assumptions or limitations. Additionally, consider using tools or frameworks that generate documentation from your code comments. This makes it easier for other developers to understand and use your code. 7. Code formatting. Consistent code formatting improves readability and makes your code easier to understand. Follow a consistent indentation style, use proper spacing, and adopt a naming convention for variables and functions. Many programming languages have style guides or linters that can automatically enforce code formatting rules. Using such tools can help maintain a consistent code style across your project. Conclusion. Code organization and modularity are essential skills for becoming a better programmer. By following the principles of code organization and modularity, you can improve the readability, maintainability, and reusability of your code. Remember to break down your code into smaller, self-contained modules, adhere to naming conventions, and document your code effectively. By practicing good code organization, you can write cleaner, more maintainable code that is easier to collaborate on and reuse in future projects. 3.4 Error handling and exception handling. Error handling and exception handling are crucial skills for any programmer. As you write code, it's important to anticipate and handle errors that may occur during the execution of your program. By effectively managing errors and exceptions, you can improve the reliability and stability of your code. In this section, we will explore various techniques and best practices for error handling and exception handling. Understanding errors and exceptions. Errors and exceptions are two types of issues that can occur during the execution of a program. Understanding the difference between them is essential for effective error handling. Errors are typically caused by external factors or unexpected conditions that prevent the program from executing as intended. These can include hardware failures, network issues, or invalid input. Errors are often fatal and can cause the program to crash or terminate abruptly. Exceptions, on the other hand, are issues that occur within the program itself. They are typically caused by logical errors, invalid operations, or exceptional conditions that the program encounters during runtime. Exceptions can be caught and handled within the program, allowing it to gracefully recover from the error and continue execution. The try-catch block. One of the most common techniques for handling exceptions is the use of try-catch blocks. A try-catch block allows you to specify a section of code that may throw an exception and define how to handle it if it occurs. Try. Code that may throw an exception, catch, exception type 1E1. Exception handling code for exception type 1, catch, exception type 2E2. Exception handling code for exception type 2, finally. Code that will always execute, regardless of whether an exception occurred or not. In the try block, you write the code that may throw an exception. If an exception occurs, the catch blocks will be executed, depending on the type of exception thrown. You can have multiple catch blocks to handle different types of exceptions. The finally block is optional and will always execute, regardless of whether an exception occurred or not. Exception propagation. When an exception is thrown within a method, it can be caught and handled within that method or propagated up the call stack to be caught and handled by a higher level method. This process is known as exception propagation. By allowing exceptions to propagate up the call stack, you can centralize the handling of exceptions in higher level methods, making your code more modular and easier to maintain. However, it's important to strike a balance between propagating exceptions and handling them at an appropriate level. Propagating too many exceptions can clutter the code and make it harder to understand. Creating custom exceptions. In addition to handling built-in exceptions, you can also create your own custom exceptions to handle specific error conditions in your code. Custom exceptions can provide more meaningful information about the error and allow you to handle it in a specialized way. To create a custom exception, you need to define a new class that extends the exception or runtime exception class. You can then add any additional properties or methods that are relevant to your specific error condition. Public class custom exception extends exception. Custom properties and methods. Once you have defined your custom exception, you can throw it using the throw keyword within your code. If error condition. Throw new custom exception error message. By creating custom exceptions, you can provide more detailed information about the error and make your code more robust and maintainable. Logging and error reporting. In addition to handling exceptions, it's important to log and report errors effectively. Logging allows you to record information about errors and exceptions that occur during the execution of your program. This information can be invaluable for debugging and troubleshooting issues. There are various logging frameworks available that provide different levels of logging, such as debug, info, warning, and error. By logging relevant information, such as the error message, stack trace, and context, you can gain insights into the cause of the error and identify potential solutions. Error reporting involves notifying the appropriate stakeholders about the occurrence of an error. This can include sending email notifications, generating error reports, or integrating with a centralized error tracking system. By promptly reporting errors, you can ensure that they are addressed and resolved in a timely manner. Best practices for error handling. To effectively handle errors and exceptions, consider the following best practices. Catch specific exceptions. Catching specific exceptions allows you to handle different types of errors in a targeted manner. Avoid catching generic exceptions like exception unless necessary. Handle exceptions gracefully. When an exception occurs, handle it gracefully by providing appropriate error messages and taking necessary actions to recover from the error. Avoid simply ignoring exceptions or logging them without any further action. Use finally blocks. Use finally blocks to ensure that critical cleanup code, such as closing files or releasing resources, is always executed, regardless of whether an exception occurred or not. Keep error messages informative. Error messages should be clear, concise, and informative. They should provide enough information to understand the cause of the error and suggest potential solutions. Avoid excessive exception propagation. Propagate exceptions to an appropriate level in the call stack, but avoid excessive propagation that can clutter the code and make it harder to understand. Test error conditions. Test your code for different error conditions to ensure that exceptions are thrown and handled correctly. Use unit tests and integration tests to verify the behavior of your error handling code. By following these best practices, you can improve the robustness and reliability of your code when it comes to error handling and exception handling. Conclusion. Error handling and exception handling are essential skills for any programmer. By understanding the difference between errors and exceptions, using try-catch blocks, propagating exceptions effectively, creating custom exceptions, and implementing logging and error reporting, you can improve the reliability and stability of your code. Remember to follow best practices for error handling to ensure that your code gracefully handles errors and provides meaningful feedback to users. 3.5 Testing and Debugging Techniques. Testing and debugging are essential skills for any programmer. They help identify and fix errors in code, ensuring that the software functions as intended. In this section, we will explore various techniques and best practices for effective testing and debugging. 3.5.1 The importance of testing. Testing is the process of evaluating a system or component to determine whether it satisfies the specified requirements. It helps identify defects, errors, or missing functionalities in the software. By conducting thorough testing, programmers can ensure the reliability, functionality, and performance of their code. Unit testing. Unit testing is a fundamental testing technique where individual units of code, such as functions or methods, are tested in isolation. It helps verify the correctness of each unit and ensures that they work as expected. By writing unit tests, programmers can catch bugs early in the development process and prevent them from propagating to other parts of the codebase. Integration testing. Integration testing focuses on testing the interaction between different components or modules of the software. It ensures that these components work together seamlessly and produce the desired output. Integration testing helps identify issues that may arise due to the integration of different modules and ensures the overall functionality of the software. System testing. System testing involves testing the entire system as a whole to ensure that it meets the specified requirements. It verifies the behavior of the software in different scenarios and ensures that it performs as expected in real-world conditions. System testing helps identify any issues that may arise due to the interaction between different components or external dependencies. Automated testing. Automated testing involves the use of tools and scripts to automate the execution of tests. It helps save time and effort by automatically running tests and generating reports. Automated testing is particularly useful for running repetitive tests, regression testing, and ensuring the stability of the codebase. Test-driven development (TDD). Test-driven development (TDD) is a development approach where tests are written before the actual code. It follows a cycle of writing a failing test, writing the minimum code required to pass the test, and then refactoring the code. TDD helps ensure that the code is thoroughly tested and that new features or changes do not introduce regressions. 3.5.2 Debugging Techniques. Debugging is the process of identifying and fixing errors or bugs in the code. It requires a systematic approach and a good understanding of the codebase. Here are some techniques and best practices for effective debugging. Reproducing the issue. To debug a problem, it is crucial to be able to reproduce the issue consistently. This involves identifying the steps or conditions that lead to the error. By reproducing the issue, programmers can isolate the problem and focus on finding a solution. Using debugging tools. Debugging tools, such as debuggers and logging frameworks, are invaluable for identifying and fixing errors. Debuggers allow programmers to step through the code, inspect variables, and track the flow of execution. Logging frameworks help capture relevant information during runtime, making it easier to trace the cause of an issue. Debugging by print statements. Print statements are a simple yet effective debugging technique. By strategically placing print statements in the code, programmers can track the flow of execution and inspect the values of variables at different points. Print statements are particularly useful for identifying the state of the program when an error occurs. Binary search debugging. Binary search debugging involves systematically narrowing down the possible causes of an error. By dividing the codebase into halves and testing each half, programmers can quickly identify the section of code where the error originates. This technique helps narrow down the search space and speeds up the debugging process. Rubber duck debugging. Rubber duck debugging is a technique where programmers explain their code line by line to an inanimate object, such as a rubber duck. By verbalizing their thoughts and explaining the code, programmers often gain new insights and identify the cause of the problem. Rubber duck debugging helps programmers approach the code from a different perspective and find solutions. Collaborative debugging. Debugging can be a collaborative effort, especially in a team setting. By discussing the problem with colleagues or seeking help from online communities, programmers can benefit from fresh perspectives and insights. Collaborative debugging can lead to faster problem solving and the discovery of alternative solutions. Conclusion. Testing and debugging are crucial skills for programmers. By following best practices and using effective techniques, programmers can ensure the reliability and functionality of their code. Thorough testing helps catch bugs early, while systematic debugging techniques help identify and fix errors efficiently. By mastering these skills, programmers can become better at their craft and deliver high-quality software. 3.6 Code review and collaboration. Code review and collaboration are essential aspects of becoming a better programmer. They help improve the quality of your code, enhance your problem-solving skills, and foster a collaborative and productive work environment. In this section, we will explore the importance of code review and collaboration, as well as some best practices to follow. The importance of code review. Code review is the process of examining and evaluating code written by yourself or others. It plays a crucial role in ensuring the quality, readability, and maintainability of the codebase. Here are some key reasons why code review is important. Bug detection. Code review helps identify bugs, logic errors, and potential issues before they make their way into production. By having multiple sets of eyes review the code, you can catch mistakes that may have been overlooked during development. Knowledge sharing. Code review provides an opportunity for team members to learn from each other. By reviewing code written by others, you can gain insights into different coding styles, techniques, and best practices. This knowledge sharing helps improve the overall skill set of the team. Consistency and standards. Code review ensures that the codebase adheres to established coding standards and guidelines. It promotes consistency in coding style, naming conventions, and code organization. Consistent code is easier to read, understand, and maintain. Continuous improvement. Code review encourages continuous improvement by providing feedback and suggestions for enhancement. It helps identify areas where code can be optimized, refactored, or simplified. Through constructive feedback, developers can learn from their mistakes and grow as programmers. Best practices for code review. To make the most out of code review, it is important to follow some best practices. Here are some guidelines to consider. Establish clear guidelines. Define clear guidelines and expectations for code review within your team or organization. This includes the frequency of code reviews, the roles and responsibilities of reviewers, and the criteria for approving or rejecting code changes. Review small chunks of code. Break down code changes into smaller, manageable chunks for review. This allows reviewers to focus on specific areas and provide more detailed feedback. It also makes it easier to track changes and understand the impact of each modification. Provide constructive feedback. When providing feedback during code review, focus on constructive criticism. Be specific about the issues you identify and suggest possible solutions. Avoid personal attacks or negative language that may discourage the developer. Encourage discussion and collaboration. Code review should be a collaborative process. Encourage developers to ask questions, seek clarification, and engage in discussions. This fosters a learning environment where team members can share their knowledge and perspectives. Automate code review. Consider using automated tools and linters to perform static code analysis. These tools can help identify common coding errors, enforce coding standards, and provide suggestions for improvement. However, remember that automated tools are not a substitute for human code review. Balance speed and thoroughness. Strive for a balance between thorough code review and timely delivery. While it is important to catch as many issues as possible, it is equally important to avoid unnecessary delays. Find the right balance that suits the needs of your project and team. Follow up on feedback. After code review, it is important to follow up on the feedback provided. Address the identified issues, make necessary changes, and communicate the resolution to the reviewers. This demonstrates your commitment to improving the code quality and shows respect for the reviewer's time and effort. Collaborative development. Collaboration is a fundamental aspect of software development. Working together with other developers can lead to better solutions, increased productivity, and a more enjoyable work environment. Here are some practices to foster collaboration. Effective communication. Communication is key to successful collaboration. Clearly communicate your ideas, requirements, and concerns to your team members. Use tools like instant messaging, email, or project management software to facilitate communication. Version control systems. Use a version control system, VCS, like Git to manage code changes and collaborate with others. VCS allows multiple developers to work on the same codebase simultaneously, track changes, and merge modifications seamlessly. Branching strategies. Adopt a branching strategy that suits your project's needs. Branching allows developers to work on features or bug fixes independently without interfering with the main codebase. It also enables parallel development and facilitates code review before merging changes. Collaboration tools. Utilize collaboration tools like issue trackers, project management software, and code review platforms. These tools help streamline communication, track progress, and facilitate code review and collaboration. Pair programming. Consider practicing pair programming, where two developers work together on the same codebase simultaneously. This approach promotes knowledge sharing, immediate feedback, and better code quality. Code documentation. Document your code to make it easier for others to understand and collaborate. Use meaningful variable and function names, add comments where necessary, and provide clear documentation for APIs and interfaces. Respect and empathy. Show respect and empathy towards your team members. Be open to their ideas, value their opinions, and provide support when needed. Collaboration thrives in an environment where everyone feels valued and respected. By embracing code review and collaboration, you can enhance your programming skills, produce higher quality code, and contribute to a more productive and harmonious work environment. Remember, becoming a better programmer is not just about writing code, it's also about working effectively with others and continuously improving your skills. 4. Understanding algorithms and data structures. 4.1 Common data structures. Data structures are fundamental building blocks in programming that allow us to store and organize data efficiently. As a programmer, it is essential to have a solid understanding of common data structures and their characteristics. In this section, we will explore some of the most commonly used data structures and their applications. Arrays. An array is a collection of elements of the same type, stored in contiguous memory locations. It provides random access to its elements, making it efficient for accessing and manipulating data. Arrays have a fixed size, which is determined at the time of declaration. Arrays are widely used in programming for various purposes. They are particularly useful when dealing with large amounts of data that need to be accessed quickly. Some common applications of arrays include storing and processing lists of numbers, characters, or objects. Linked lists. A linked list is a data structure that consists of a sequence of nodes, where each node contains a value and a reference to the next node in the list. Unlike arrays, linked lists do not require contiguous memory allocation, allowing for dynamic memory allocation and efficient insertion and deletion operations. Linked lists are commonly used when the size of the data is unknown or may change frequently. They are particularly useful for implementing stacks, queues, and other dynamic data structures. However, linked lists have slower access times compared to arrays since elements must be traversed sequentially. Stacks. A stack is a data structure that follows the last in first out (LIFO) principle. It allows for two main operations: push, which adds an element to the top of the stack, and pop, which removes the top element from the stack. Stacks can be implemented using arrays or linked lists. Stacks are widely used in programming for various purposes. They are particularly useful for solving problems that involve nested structures, such as parentheses matching, function call tracking, and expression evaluation. Stacks also play a crucial role in recursive algorithms and backtracking. Queues. A queue is a data structure that follows the first in first out (FIFO) principle. It allows for two main operations: enqueue, which adds an element to the end of the queue, and dequeue, which removes the front element from the queue. Queues can be implemented using arrays or linked lists. Queues are commonly used in programming for managing processes, scheduling tasks, and handling requests. They are particularly useful in scenarios where the order of operations is critical, such as in breadth-first search algorithms and simulations. Hash tables. A hash table, also known as a hash map, is a data structure that provides fast access to data by using a hash function to map keys to values. It allows for efficient insertion, deletion, and retrieval operations. Hash tables are typically implemented using arrays and linked lists. Hash tables are widely used in programming for various purposes, including caching, indexing, and data lookup. They are particularly useful when there is a need for fast access to data based on a unique identifier. However, hash tables may have collisions, which can affect their performance. Trees. A tree is a hierarchical data structure that consists of nodes connected by edges. Each node can have 0 or more child nodes, except for the root node, which has no parent. Trees are commonly used to represent hierarchical relationships between data. Trees have various applications in programming, such as representing file systems, organizing data in databases, and implementing search algorithms like binary search trees. They are also used in graph theory and artificial intelligence algorithms. Graphs. A graph is a collection of nodes, also known as vertices, connected by edges. Graphs can be either directed or undirected, depending on whether the edges have a specific direction. Graphs are used to represent relationships between objects or entities. Graphs have numerous applications in programming, including social networks, routing algorithms, and recommendation systems. They are also used in solving complex problems, such as finding the shortest path between two nodes or detecting cycles in a network. Conclusion. Understanding common data structures is crucial for becoming a better programmer. Each data structure has its own strengths and weaknesses, and choosing the right one for a specific problem can significantly impact the efficiency and performance of your code. By familiarizing yourself with these common data structures and their applications, you will be better equipped to solve complex programming problems and write efficient and scalable code. 4.2 Sorting and searching algorithms. Sorting and searching are fundamental operations in computer science and play a crucial role in programming. As a programmer, it is essential to understand various sorting and searching algorithms and their implementations. This knowledge will enable you to choose the most efficient algorithm for a given problem and optimize the performance of your code. Sorting algorithms. Sorting algorithms are used to arrange a collection of elements in a specific order, such as ascending or descending. There are numerous sorting algorithms available, each with its own advantages and disadvantages. Let's explore some commonly used sorting algorithms. 1. Bubble sort. Bubble sort is a simple and intuitive sorting algorithm. It repeatedly compares adjacent elements and swaps them if they are in the wrong order. The process continues until the entire collection is sorted. Bubble sort has a time complexity of O(n squared), in the worst case, making it inefficient for large datasets. 2. Selection sort. Selection sort works by repeatedly finding the minimum element from the unsorted part of the collection and placing it at the beginning. This process continues until the entire collection is sorted. Selection sort also has a time complexity of O(n squared), in the worst case. 3. Insertion sort. Insertion sort builds the final sorted array one element at a time. It iterates through the collection, comparing each element with the already sorted portion and inserting it at the correct position. Insertion sort has a time complexity of O(n squared), in the worst case, but performs well on small datasets or partially sorted collections. 4. Merge sort. Merge sort is a divide and conquer algorithm that divides the collection into smaller subproblems, sorts them, and then merges them to obtain the final sorted collection. It has a time complexity of O(n log n), in all cases, making it more efficient than the previous sorting algorithms. Merge sort is widely used due to its stability and consistent performance. 5. Quick sort. Quick sort is another divide and conquer algorithm that selects a pivot element and partitions the collection into two subarrays, one with elements smaller than the pivot and the other with elements greater than the pivot. It then recursively sorts the subarrays. Quick sort has an average time complexity of O(n log n), but can degrade to O(n squared), in the worst case. However, it is often faster in practice than other sorting algorithms. 6. Heap sort. Heap sort uses a binary heap data structure to sort the collection. It first builds a max heap from the elements and then repeatedly extracts the maximum element and places it at the end of the sorted portion. Heap sort has a time complexity of O(n log n), in all cases, and is often used when a stable sort is not required. 7. Radix sort. Radix sort is a non-comparative sorting algorithm that sorts the elements by their individual digits or bits. It works by distributing the elements into buckets based on the least significant digit, then repeatedly redistributing them based on the next significant digit until the entire collection is sorted. Radix sort has a time complexity of O(k)n), where k is the number of digits or bits in the largest element. Searching algorithms. Searching algorithms are used to find the presence or position of a specific element within a collection. Let's explore some commonly used searching algorithms. 1. Linear search. Linear search is the simplest searching algorithm. It sequentially checks each element in the collection until it finds the target element or reaches the end. Linear search has a time complexity of O(n), in the worst case, where n is the size of the collection. It is suitable for smaller unsorted collections. 2. Binary search. Binary search is a divide-and-conquer algorithm that works on sorted collections. It repeatedly divides the collection in half and compares the middle element with the target element. If they match, the search is successful. Otherwise, it continues searching in the appropriate half until the target element is found or the collection is exhausted. Binary search has a time complexity of O log n, in the worst case, making it highly efficient for large sorted collections. 3. Hashing. Hashing is a technique that maps elements to an index using a hash function. It allows for constant time retrieval of elements if the hash function is well designed. Hashing is commonly used in data structures like hash tables and dictionaries to provide efficient searching and retrieval operations. 4. Interpolation search. Interpolation search is an improved version of binary search that works on uniformly distributed sorted collections. It estimates the position of the target element based on the values of the first and last elements. It then performs a binary search-like operation to narrow down the search range. Interpolation search has an average time complexity of O log n, but can degrade to O(n) in the worst case. 5. Ternary search. Ternary search is a divide-and-conquer algorithm that works on sorted collections. It repeatedly divides the collection into 3 parts and compares the target element with the values at the 2 division points. Based on the comparison, it narrows down the search range to one of the 3 parts. Ternary search has a time complexity of O log 3n in the worst case. Understanding and implementing these sorting and searching algorithms will enhance your problem-solving skills and enable you to choose the most appropriate algorithm for a given scenario. It is important to consider factors such as the size of the collection, the order of the elements, and the desired time complexity when selecting an algorithm. Additionally, analyzing the problem requirements and constraints will help you determine the most efficient approach to sorting and searching. 4.3. Graphs and trees. Graphs and trees are fundamental data structures in computer science and are widely used in various applications. Understanding these data structures and their associated algorithms is essential for becoming a better programmer. In this section, we will explore the concepts of graphs and trees, their properties, and how to work with them effectively. Graphs. A graph is a collection of nodes, also known as vertices, connected by edges. It is a versatile data structure that can represent relationships between objects. Graphs can be used to model social networks, transportation networks, computer networks, and more. Types of graphs. There are several types of graphs, each with its own characteristics. Undirected graph. In an undirected graph, the edges have no direction. The relationship between nodes is symmetric, meaning that if node A is connected to node B, then node B is also connected to node A. Directed graph digraph. In a directed graph, the edges have a direction. The relationship between nodes is asymmetric, meaning that if node A is connected to node B, it does not necessarily imply that node B is connected to node A. Weighted graph. In a weighted graph, each edge has a weight or cost associated with it. These weights can represent distances, costs, or any other relevant metric. Cyclic graph. A cyclic graph contains at least one cycle, which is a path that starts and ends at the same node. Acyclic graph. An acyclic graph does not contain any cycles. Representing graphs. There are multiple ways to represent graphs in computer memory. The 2 most common representations are adjacency matrix. An adjacency matrix is a 2-dimensional array where each cell represents the presence or absence of an edge between 2 nodes. This representation is efficient for dense graphs but can be memory-intensive for sparse graphs. Adjacency list. An adjacency list is a collection of linked lists or arrays, where each node has a list of its adjacent nodes. This representation is efficient for sparse graphs but requires more memory for dense graphs. Graph traversal. Graph traversal is the process of visiting all the nodes in a graph. There are 2 popular graph traversal algorithms. Breadth first search BFS. BFS explores all the vertices of a graph in breadth first order. It starts at a given node and visits all its neighbors before moving on to the next level of neighbors. BFS is commonly used to find the shortest path between 2 nodes. Depth first search DFS. DFS explores all the vertices of a graph in depth first order. It starts at a given node and explores as far as possible along each branch before backtracking. DFS is commonly used to detect cycles in a graph and to explore all possible paths. Trees. A tree is a special type of graph that does not contain any cycles. It consists of nodes connected by edges, where each node, except the root, has exactly one parent node. Trees are widely used in data structures, algorithms, and database systems. Terminology. Before diving into tree algorithms, let's familiarize ourselves with some common tree terminology. Root. The root is the topmost node of a tree. It has no parent. Parent. A parent node is a node that has one or more child nodes. Child. A child node is a node that has a parent node. Leaf. A leaf node is a node that has no children. Sibling. Sibling nodes share the same parent. Binary trees. A binary tree is a tree in which each node has at most 2 children, referred to as the left child and the right child. Binary trees are commonly used in search algorithms, sorting algorithms, and expression evaluation. Binary search trees. A binary search tree (BST) is a binary tree with the following properties. The left subtree of a node contains only nodes with values less than the node's value. The right subtree of a node contains only nodes with values greater than the node's value. Both the left and right subtrees are also binary search trees. BSTs are efficient for searching, inserting, and deleting elements in logarithmic time complexity. Tree traversal. Tree traversal is the process of visiting all the nodes in a tree. There are three popular tree traversal algorithms. Preorder traversal. In preorder traversal, we visit the root node first, followed by the left subtree, and then the right subtree. In-order traversal. In in-order traversal, we visit the left subtree first, followed by the root node, and then the right subtree. In binary search trees, in-order traversal visits the nodes in ascending order. Post-order traversal. In post-order traversal, we visit the left subtree first, followed by the right subtree, and then the root node. Balancing trees. Balancing trees are special types of trees that maintain a balanced structure, ensuring efficient operations. Some popular balancing trees include AVL tree. An AVL tree is a self-balancing binary search tree. It maintains a balance factor for each node, ensuring that the heights of the left and right subtrees differ by at most 1. Red-black tree. A red-black tree is another self-balancing binary search tree. It ensures that the tree remains balanced by applying specific rules, such as coloring nodes red or black. Balancing trees are crucial for maintaining optimal performance in scenarios where the tree is frequently modified. Conclusion. Graphs and trees are essential data structures that every programmer should understand. They provide powerful ways to model relationships and solve complex problems efficiently. By mastering the concepts and algorithms associated with graphs and trees, you will become a more versatile and effective programmer. 4.4. Dynamic programming. Dynamic programming is a powerful problem-solving technique that can greatly improve the efficiency and performance of your code. It is particularly useful when dealing with problems that can be broken down into smaller overlapping subproblems. In this section, we will explore the concept of dynamic programming and learn how to apply it to solve complex programming problems. Understanding dynamic programming. Dynamic programming is an algorithmic optimization technique that solves complex problems by breaking them down into simpler subproblems and solving each subproblem only once. The key idea behind dynamic programming is to store the solutions to subproblems in a table or an array, so that they can be reused when needed. The main advantage of dynamic programming is that it avoids redundant computations by solving each subproblem only once and storing its solution for future use. This can lead to significant performance improvements, especially for problems with overlapping subproblems. The steps of dynamic programming. To apply dynamic programming to a problem, you typically follow these steps. Identify the problem. Understand the problem and determine if it can be solved using dynamic programming. Look for patterns or subproblems that can be solved independently. Define the state. Identify the variables or parameters that define the state of the problem. The state represents the information needed to solve a particular subproblem. Formulate the recurrence relation. Express the solution to the problem in terms of solutions to smaller subproblems. This is often done using a recursive formula or equation. Design the algorithm. Determine the order in which the subproblems should be solved and how to store their solutions. This may involve using a table or an array to store the solutions. Implement the algorithm. Write the code to solve the problem using the dynamic programming approach. Make sure to handle the base cases and initialize the table or array properly. Analyze the time and space complexity. Evaluate the efficiency of your dynamic programming solution in terms of time and space complexity. This will help you understand the performance characteristics of your algorithm. Examples of dynamic programming problems. Dynamic programming can be applied to a wide range of problems. Here are a few examples to illustrate its usage. Fibonacci sequence. The Fibonacci sequence is a classic example of a problem that can be solved using dynamic programming. The sequence is defined as follows. Each number in the sequence is the sum of the two preceding ones, starting from 0 and 1. By using dynamic programming, we can avoid redundant computations and calculate the Fibonacci numbers efficiently. Knapsack problem. The knapsack problem is a well-known optimization problem in computer science. Given a set of items with weights and values, the goal is to determine the most valuable combination of items that can be carried in a knapsack of limited capacity. Dynamic programming can be used to solve this problem by breaking it down into smaller subproblems and storing the solutions in a table. Longest common subsequence. The longest common subsequence problem is another example where dynamic programming can be applied. Given two sequences, the goal is to find the longest subsequence that is common to both sequences. By using dynamic programming, we can efficiently solve this problem by breaking it down into smaller subproblems and storing the solutions in a table. Tips for using dynamic programming. Here are some tips to keep in mind when using dynamic programming. Identify the optimal substructure. Dynamic programming works best when the problem can be divided into smaller subproblems that can be solved independently. Look for patterns or subproblems that can be solved separately and combined to obtain the optimal solution. Avoid redundant computations. The key advantage of dynamic programming is that it avoids redundant computations by storing the solutions to subproblems. Make sure to reuse the stored solutions whenever possible to improve the efficiency of your algorithm. Start with a small problem. When applying dynamic programming, it can be helpful to start with a small problem and manually solve it using a bottom-up approach. This will give you a better understanding of the subproblems and how they can be combined to solve the larger problem. Use memoization. Memoization is a technique used in dynamic programming to store the solutions to subproblems in a cache or a memo. This can help improve the efficiency of your algorithm by avoiding redundant computations. Practice and analyze. Dynamic programming can be challenging at first, but with practice, you will become more comfortable with identifying subproblems and formulating the recurrence relations. Analyze the time and space complexity of your solutions to understand their performance characteristics. Conclusion. Dynamic programming is a powerful technique that can greatly improve the efficiency and performance of your code. By breaking down complex problems into smaller subproblems and reusing their solutions, you can solve problems more efficiently and avoid redundant computations. Understanding the steps of dynamic programming and practicing its application will help you become a better programmer and solve complex problems with ease. 5. Efficient problem solving. 5.1 Problem analysis and breakdown. Problem analysis and breakdown is a crucial skill for every programmer. Before diving into writing code, it is essential to thoroughly understand the problem at hand and break it down into smaller, manageable components. This process allows you to gain a clear understanding of the problem, identify potential challenges, and develop an effective solution. In this section, we will explore the importance of problem analysis and breakdown and provide you with practical techniques to improve your problem-solving skills. Understanding the problem. The first step in problem analysis is to fully comprehend the problem statement. Take the time to read and reread the problem statement, ensuring that you have a clear understanding of what is being asked. It is essential to identify the inputs, outputs, and any constraints or requirements specified in the problem. Once you have a solid grasp of the problem, break it down into smaller sub-problems or tasks. This breakdown helps you tackle the problem in a systematic and organized manner. By breaking the problem into smaller components, you can focus on solving each part individually, making the overall problem more manageable. Identifying key components. When breaking down a problem, it is crucial to identify the key components or elements involved. These components can be data structures, algorithms, or specific functionalities required to solve the problem. By identifying these components, you can better understand the problem's complexity and determine the most efficient approach to solve it. For example, if you are tasked with developing a program to sort a list of numbers, the key components may include selecting an appropriate sorting algorithm, understanding the data structure of the list, and implementing the necessary logic to perform the sorting operation. Analyzing constraints and requirements. Every problem comes with its own set of constraints and requirements. These constraints may include limitations on time, memory, or computational resources. Understanding these constraints is crucial as they can significantly impact the design and implementation of your solution. Additionally, it is essential to analyze the requirements of the problem. What are the expected outputs? Are there any specific input formats or restrictions? By thoroughly analyzing the constraints and requirements, you can ensure that your solution meets the desired specifications. Developing a plan. Once you have analyzed the problem and identified its key components, it is time to develop a plan of action. This plan outlines the steps you will take to solve the problem and serves as a roadmap for your implementation. Start by outlining the high-level approach you will take to solve the problem. Break down the problem into smaller sub-problems and determine the order in which you will tackle them. Consider the dependencies between these sub-problems and identify any potential bottlenecks or challenges. Next, dive deeper into each sub-problem and develop a detailed plan for solving it. Consider the algorithms, data structures, and techniques you will use. Think about edge cases and potential error scenarios, and plan how you will handle them. Testing and refining the plan. Once you have developed a plan, it is crucial to test and refine it. Implement a prototype or a simplified version of your solution and test it with various inputs. This testing phase helps you identify any flaws or shortcomings in your plan and allows you to make necessary adjustments. During the testing phase, pay attention to the correctness and efficiency of your solution. Does it produce the expected outputs for different inputs? Is it performing within the desired time and space constraints? Use this feedback to refine your plan and make any necessary optimizations. Iterative problem solving. Problem analysis and breakdown is an iterative process. As you implement and test your solution, you may encounter new challenges or discover better approaches. It is essential to be open to feedback and continuously refine your plan. If you encounter difficulties in solving a particular sub-problem, consider breaking it down further or seeking help from other resources such as online forums or colleagues. Collaboration and seeking different perspectives can often lead to innovative solutions. Summary. Problem analysis and breakdown are fundamental skills for every programmer. By thoroughly understanding the problem, identifying key components, analyzing constraints and requirements, and developing a well-defined plan, you can approach problem solving in a systematic and efficient manner. Remember to test and refine your plan iteratively, and be open to feedback and collaboration. With practice, you will become a better problem solver and programmer. 5.2 Algorithm Design and Optimization. In the world of programming, algorithms play a crucial role in solving problems efficiently. An algorithm is a step-by-step procedure or a set of rules for solving a specific problem. It is the backbone of any program and determines how efficiently a task can be accomplished. In this section, we will explore the importance of algorithm design and optimization and learn techniques to improve the efficiency of our code. Understanding algorithm design. Algorithm design is the process of creating a well-structured and efficient algorithm to solve a problem. It involves breaking down a complex problem into smaller, manageable subproblems and designing a solution for each subproblem. A well-designed algorithm should be correct, efficient, and easy to understand. To design an algorithm, you need to have a clear understanding of the problem at hand. Start by analyzing the problem requirements and constraints. Identify the inputs and outputs of the problem and determine the steps required to transform the inputs into the desired outputs. This process is known as problem analysis and breakdown, which we discussed in the previous section. Once you have a clear understanding of the problem, you can start designing the algorithm. There are various techniques and strategies you can use, such as 1. Divide and conquer. The divide and conquer strategy involves breaking down a problem into smaller subproblems, solving each subproblem independently, and combining the solutions to obtain the final result. This technique is commonly used in sorting and searching algorithms like merge sort and binary search. 2. Greedy algorithms. Greedy algorithms make locally optimal choices at each step to find the global optimum. They are useful when a problem can be solved by making a series of greedy choices. However, greedy algorithms may not always produce the optimal solution for every problem. 3. Dynamic programming. Dynamic programming is a technique used to solve problems by breaking them down into overlapping subproblems and solving each subproblem only once. The solutions to subproblems are stored in a table and reused when needed. This technique is particularly useful for solving optimization problems. 4. Backtracking. Backtracking is a technique used to systematically explore all possible solutions to a problem by incrementally building a solution and undoing the choices that lead to a dead end. It is commonly used in solving problems like the n-queens problem and Sudoku. 5. Branch and bound. Branch and bound is a technique used to solve optimization problems by systematically exploring the search space and pruning branches that are guaranteed to lead to suboptimal solutions. It is commonly used in solving problems like the traveling salesman problem. Optimizing algorithm efficiency. Once you have designed an algorithm, the next step is to optimize its efficiency. Optimizing an algorithm involves reducing its time complexity and space complexity, which directly impact the performance of your code. Time complexity analysis. Time complexity measures the amount of time an algorithm takes to run as a function of the input size. It helps us understand how the algorithm's performance scales with larger inputs. Common time complexity notations include O(1), O log n, O n, O n log n, O n squared, and O(2) caret n. To analyze the time complexity of an algorithm, you can count the number of basic operations performed as a function of the input size. Ignore constant factors and lower order terms, focusing on the dominant term that grows the fastest. This will give you an approximation of the algorithm's time complexity. Space complexity analysis. Space complexity measures the amount of memory an algorithm requires as a function of the input size. It helps us understand how much memory the algorithm consumes. Common space complexity notations include O(1), O log n, O n, O n log n, O n squared, and O(2) caret n. To analyze the space complexity of an algorithm, you can count the amount of memory used by variables, data structures, and recursive calls as a function of the input size. Similar to time complexity analysis, focus on the dominant term that grows the fastest. Optimization techniques. There are several techniques you can use to optimize your algorithms. Memoization. Memoization is a technique used in dynamic programming to store the results of expensive function calls and reuse them when the same inputs occur again. It can significantly improve the performance of recursive algorithms. Loop unrolling. Loop unrolling is a technique used to reduce loop overhead by manually duplicating loop iterations. It can improve the performance of loops by reducing the number of branch instructions and improving cache utilization. Data structure selection. Choosing the right data structure can have a significant impact on the efficiency of your algorithms. For example, using a hash table instead of an array for fast lookups or a linked list instead of an array for efficient insertions and deletions. Parallelization. Parallelization involves dividing a task into smaller subtasks that can be executed simultaneously on multiple processors or threads. It can improve the performance of algorithms that can be parallelized, such as sorting and matrix multiplication. Algorithmic improvements. Sometimes, a simple change in the algorithm can lead to significant performance improvements. For example, using a more efficient sorting algorithm or optimizing a recursive algorithm by eliminating redundant calculations. By understanding algorithm design principles and applying optimization techniques, you can significantly improve the efficiency of your code. Remember to always analyze the time and space complexity of your algorithms and strive for the most efficient solution. 5.3. Time and space complexity analysis. In order to become a better programmer, it is essential to have a solid understanding of time and space complexity analysis. This concept plays a crucial role in evaluating the efficiency and performance of algorithms and data structures. By analyzing the time and space complexity of your code, you can make informed decisions about optimizing your programs and improving their overall efficiency. Understanding time complexity. Time complexity refers to the amount of time it takes for an algorithm to run as a function of the input size. It helps us understand how the execution time of an algorithm grows with the increase in input size. Time complexity is usually expressed using big O notation, which provides an upper bound on the growth rate of an algorithm. Big O notation. Big O notation is a mathematical notation used to describe the upper bound or worst-case scenario of an algorithm's time complexity. It allows us to compare the efficiency of different algorithms by ignoring constant factors and lower-order terms. Here are some commonly used big O notations. O1. Constant time complexity. The algorithm takes the same amount of time regardless of the input size. O log n. Logarithmic time complexity. The algorithm's execution time increases logarithmically with the input size. O n. Linear time complexity. The algorithm's execution time increases linearly with the input size. O n log n. Logarithmic time complexity. The algorithm's execution time increases linearly multiplied by the logarithm of the input size. O n squared. Quadratic time complexity. The algorithm's execution time increases quadratically with the input size. O2 caret n. Exponential time complexity. The algorithm's execution time doubles with each additional input element. Analyzing time complexity. To analyze the time complexity of an algorithm, you need to determine how the execution time grows as the input size increases. This can be done by examining the number of iterations, comparisons, or operations performed by the algorithm. Here are some common techniques for analyzing time complexity. Counting operations. Identify the key operations performed in the algorithm and determine how many times they are executed based on the input size. Loop analysis. Analyze the number of iterations in loops and nested loops. Consider the worst-case scenario. Recurrence relations. For recursive algorithms, define a recurrence relation that describes the time complexity in terms of smaller input sizes. Mathematical analysis. Use mathematical techniques such as summations and logarithms to derive the time complexity equation. Understanding space complexity. Space complexity refers to the amount of memory or space required by an algorithm to solve a problem as a function of the input size. It helps us understand how the memory usage of an algorithm grows with the increase in input size. Similar to time complexity, space complexity is also expressed using big O notation. Analyzing space complexity. To analyze the space complexity of an algorithm, you need to determine how the memory usage grows as the input size increases. This can be done by examining the variables, data structures, and recursive calls used by the algorithm. Here are some common techniques for analyzing space complexity. Counting variables. Identify the number of variables used by the algorithm and determine their memory requirements. Data structure analysis. Analyze the memory usage of data structures such as arrays, lists, trees, and graphs. Recursive calls. Determine the memory required for each recursive call and analyze how it grows with the input size. Auxiliary space. Consider any additional space used by the algorithm, such as temporary arrays or stacks. Importance of time and space complexity analysis. Time and space complexity analysis is crucial for several reasons. Performance optimization. By understanding the time and space complexity of your code, you can identify bottlenecks and optimize critical sections of your program. This can lead to significant improvements in execution time and memory usage. Algorithm selection. When faced with multiple algorithms to solve a problem, time and space complexity analysis can help you choose the most efficient one. It allows you to compare the performance of different algorithms and select the one that best suits your requirements. Scalability. As the input size increases, inefficient algorithms can quickly become impractical or even fail to produce results. Time and space complexity analysis helps you design algorithms that can handle larger inputs efficiently. Resource management. Understanding the memory requirements of your code is essential for managing system resources effectively. By analyzing space complexity, you can ensure that your program does not consume excessive memory, leading to crashes or slowdowns. Best practices for time and space complexity analysis. To effectively analyze the time and space complexity of your code, consider the following best practices. Understand the problem. Before analyzing the complexity, make sure you have a clear understanding of the problem and the requirements. This will help you identify the key operations and data structures involved. Use big O notation. Express the time and space complexity using big O notation. It provides a standardized way to compare algorithms and simplifies complexity analysis. Focus on worst-case scenario. Analyze the worst-case scenario of your algorithm, as it provides an upper bound on the execution time and memory usage. Consider trade-offs. Sometimes, optimizing for time complexity may result in increased space complexity, and vice versa. Consider the trade-offs and choose the approach that best suits your requirements. Test and validate. Validate your complexity analysis by testing your code with different input sizes. Measure the execution time and memory usage to ensure they align with your analysis. By mastering time and space complexity analysis, you can become a more efficient and effective programmer. It allows you to design and implement algorithms that are optimized for performance and resource usage. Understanding the impact of your code on time and space complexity is a valuable skill that will help you tackle complex problems and deliver high-quality software solutions. 5.4 Optimizing code performance. Optimizing code performance is a crucial skill for any programmer. Writing efficient and fast code not only improves the overall user experience but also reduces resource consumption and costs. In this section, we will explore various techniques and strategies to optimize code performance. Understanding performance optimization. Performance optimization involves identifying and resolving bottlenecks in your code that may be causing it to run slower than desired. It requires a deep understanding of the underlying programming language, algorithms, and data structures. By optimizing code performance, you can significantly improve the execution time and resource utilization of your programs. Profiling your code. Before you can optimize your code, it's essential to identify the areas that need improvement. Profiling is the process of analyzing your code's execution to determine which parts are consuming the most resources or taking the longest time to execute. There are various profiling tools available for different programming languages that can help you identify performance bottlenecks. Profiling tools provide valuable insights into the execution time, memory usage, and function call hierarchy of your code. By analyzing the profiling results, you can pinpoint specific areas that require optimization. Common performance bottlenecks include inefficient algorithms, excessive memory usage, and unnecessary function calls. Algorithmic optimization. One of the most effective ways to optimize code performance is by improving the algorithms used in your code. A well-designed algorithm can significantly reduce the execution time and resource consumption of your program. Here are a few techniques to consider. 1. Choose the right data structure. Selecting the appropriate data structure for your problem can have a significant impact on performance. For example, using a hash table instead of an array for fast lookups or a linked list instead of an array for efficient insertions and deletions can improve overall performance. 2. Use efficient sorting and searching algorithms. Sorting and searching operations are common in many programs. Choosing the right sorting or searching algorithm can greatly improve performance. For example, using quicksort instead of bubble sort for sorting large datasets can significantly reduce execution time. 3. Implement memoization. Memoization is a technique where you store the results of expensive function calls and reuse them when the same inputs occur again. This technique can be particularly useful in recursive algorithms to avoid redundant calculations and improve performance. 4. Reduce redundant operations. Analyze your code for redundant operations that can be eliminated. For example, unnecessary loops, duplicate calculations, or redundant function calls can be optimized to improve performance. Code-level optimization. In addition to algorithmic optimization, there are several code-level techniques that can help improve performance. These techniques focus on optimizing individual lines of code or specific sections of your program. Here are some strategies to consider. 1. Minimize memory usage. Excessive memory usage can slow down your program and even lead to memory-related errors. Avoid unnecessary memory allocations and deallocations by reusing objects or using more efficient data structures. Additionally, consider using data compression techniques or optimizing data storage formats to reduce memory consumption. 2. Optimize loops. Loops are often a significant source of performance bottlenecks. To optimize loops, minimize the number of iterations, reduce the number of conditional statements within the loop, and avoid unnecessary calculations or function calls inside the loop. 3. Use bitwise operations. Bitwise operations can be significantly faster than arithmetic operations in some cases. Utilize bitwise operations when appropriate, especially for tasks like bit manipulation, flag checking, or bitwise comparisons. 4. Avoid string concatenation in loops. String concatenation within loops can be inefficient, especially when dealing with large strings or a large number of concatenations. Instead, consider using string builder or similar constructs that provide efficient string concatenation. 5. Optimize I/O operations. Input-output I/O operations can be a significant performance bottleneck, especially when dealing with large files or networked communication. Minimize the number of I/O operations, use buffered I/O streams, and consider asynchronous I/O techniques to improve performance. Testing and benchmarking. After implementing performance optimizations, it's crucial to test and benchmark your code to ensure that the changes have indeed improved performance. Use appropriate testing frameworks and tools to measure the execution time and resource utilization of your code before and after optimization. This will help you validate the effectiveness of your optimizations and identify any regressions. Conclusion. Optimizing code performance is an essential skill for any programmer. By understanding the principles of performance optimization, profiling your code, and implementing algorithmic and code-level optimizations, you can significantly improve the efficiency and speed of your programs. Remember to test and benchmark your code to validate the effectiveness of your optimizations. With practice and experience, you will become proficient in optimizing code performance and delivering high-quality, efficient software solutions. 6. Working with APIs and libraries. 6.1 Understanding APIs and SDKs. In today's interconnected world, APIs, application programming interfaces, and SDKs, software development kits, play a crucial role in software development. They allow developers to leverage existing functionality and services provided by other software systems, saving time and effort in building everything from scratch. Understanding how to work with APIs and SDKs is essential for becoming a better programmer. In this section, we will explore the concepts and best practices related to APIs and SDKs. What are APIs? An API is a set of rules and protocols that allows different software applications to communicate and interact with each other. It defines the methods, data formats, and authentication mechanisms that developers can use to access the functionality of a particular software system or service. APIs can be used to retrieve data, perform actions, or integrate different systems seamlessly. APIs can be categorized into different types based on their purpose and functionality. Some common types of APIs include Web APIs. These APIs are designed to be accessed over the internet using standard protocols such as HTTP. Web APIs are widely used for integrating web-based services and retrieving data from remote servers. Operating system APIs. These APIs provide access to the underlying functionality of an operating system. They allow developers to interact with system resources such as files, network connections, and hardware devices. Library APIs. Library APIs are sets of functions and classes provided by programming libraries. They offer pre-built functionality that developers can use to simplify their code and solve common programming problems. Database APIs. These APIs enable developers to interact with databases and perform operations such as querying, inserting, updating, and deleting data. What are SDKs? An SDK, on the other hand, is a collection of software tools, libraries, and documentation that developers can use to build applications for a specific platform or framework. SDKs are typically provided by the creators of the platform or framework to facilitate the development process and ensure compatibility with their systems. SDKs often include APIs as a part of their offerings. They provide a higher-level abstraction and additional tools that make it easier for developers to work with the underlying APIs. SDKs may include code samples, documentation, debugging tools, and other resources that help developers understand and utilize the platform or framework effectively. Benefits of using APIs and SDKs. Working with APIs and SDKs offers several benefits for programmers. Time and effort savings. APIs and SDKs provide pre-built functionality that developers can leverage, saving time and effort in developing everything from scratch. Instead of reinventing the wheel, developers can focus on solving specific problems and building unique features. Access to external services. APIs allow developers to integrate their applications with external services and systems. This enables them to leverage the functionality and data provided by those services, such as social media platforms, payment gateways, mapping services, and more. Consistency and standardization. APIs and SDKs provide a standardized way of interacting with different systems. This ensures consistency in data formats, authentication mechanisms, and communication protocols, making it easier to integrate multiple systems seamlessly. Ecosystem and community support. Popular APIs and SDKs often have a large community of developers who actively contribute to their improvement and provide support. This means that developers can benefit from the collective knowledge and experience of the community, making it easier to troubleshoot issues and find solutions. Best practices for working with APIs and SDKs. To make the most out of APIs and SDKs, it is important to follow some best practices. Read the documentation. Before using an API or SDK, thoroughly read the documentation provided by the provider. The documentation will explain the available functionality, usage guidelines, authentication requirements, and any limitations or restrictions. Understand the API design. APIs have their own design patterns and conventions. Familiarize yourself with the design principles and follow them consistently to ensure clean and maintainable code. Handle errors and exceptions. APIs can return errors or exceptions in various scenarios. Make sure to handle these errors gracefully and provide appropriate feedback to the user. This includes handling network errors, authentication failures, and invalid input. Test and validate inputs. Before making API calls, validate and sanitize the inputs to ensure they meet the required format and constraints. This helps prevent unexpected errors and improves the overall reliability of your code. Implement rate limiting. Some APIs have rate limits to prevent abuse and ensure fair usage. Respect these limits and implement appropriate rate limiting mechanisms in your code to avoid being blocked or banned by the API provider. Keep API keys and credentials secure. When working with APIs that require authentication, ensure that your API keys and credentials are stored securely. Avoid hardcoding them in your code or sharing them publicly. Monitor API usage and performance. Regularly monitor the usage and performance of the APIs you are using. This helps identify any issues or bottlenecks and allows you to optimize your code accordingly. By following these best practices, you can effectively work with APIs and SDKs, leverage their functionality, and build robust and reliable applications. Conclusion. Understanding APIs and SDKs is essential for modern software development. APIs enable seamless integration with external services, while SDKs provide additional tools and resources to simplify development. By leveraging APIs and SDKs effectively, developers can save time, access external functionality, and build more robust and scalable applications. Following best practices ensures clean and maintainable code, error handling, and security. 6.2 Using third-party libraries. In the world of programming, it is rare to find a project that doesn't require the use of third-party libraries. These libraries provide pre-built functionality that can save you time and effort in developing your own solutions from scratch. They offer a wide range of features and capabilities, allowing you to leverage the expertise of other developers and build upon their work. Understanding the benefits of third-party libraries. Using third-party libraries can bring numerous benefits to your programming projects. Here are some key advantages. 1. Time and effort savings. One of the most significant advantages of using third-party libraries is the time and effort they can save you. Instead of reinventing the wheel, you can leverage existing solutions that have been thoroughly tested and optimized. This allows you to focus on the unique aspects of your project and accelerate your development process. 2. Increased productivity. By utilizing third-party libraries, you can increase your productivity as a programmer. These libraries often provide high-level abstractions and intuitive APIs that simplify complex tasks. This means you can accomplish more in less time, as you don't have to delve into the intricacies of low-level implementation details. 3. Access to specialized functionality. Third-party libraries often specialize in specific domains or problem areas. By incorporating these libraries into your projects, you gain access to specialized functionality that would otherwise require extensive research and development. This allows you to deliver more robust and feature-rich applications to your users. 4. Community support and documentation. Popular third-party libraries usually have a large user base and an active community of developers. This means you can benefit from the collective knowledge and experience of other programmers who have used the library before you. Additionally, well-maintained libraries often come with comprehensive documentation, tutorials, and examples, making it easier for you to understand and utilize their features. 5. Code reusability. Using third-party libraries promotes code reusability. Once you have integrated a library into your project, you can reuse its functionality across multiple projects. This not only saves you time but also ensures consistency and reduces the chances of introducing bugs or errors. Choosing the right third-party libraries. While third-party libraries offer many advantages, it is essential to choose the right ones for your project. Here are some factors to consider when selecting a library. 1. Compatibility. Ensure that the library you choose is compatible with your programming language, framework, and version. Incompatible libraries can lead to conflicts and compatibility issues, which can be time-consuming to resolve. 2. Popularity and community support. Consider the popularity and community support of the library. Libraries with a large user base and an active community are more likely to be well-maintained, regularly updated, and have extensive documentation and support resources available. 3. Stability and reliability. Check the stability and reliability of the library by reviewing its release history, bug reports, and user feedback. A library with a track record of stability and reliability is less likely to introduce unexpected issues into your project. 4. Licensing. Review the licensing terms of the library to ensure it aligns with your project's requirements. Some libraries may have restrictive licenses that could limit your project's distribution or require additional licensing fees. 5. Performance and efficiency. Evaluate the performance and efficiency of the library. Look for benchmarks, performance metrics, or user reviews that can provide insights into the library's impact on your project's performance. 6. Security. Consider the security implications of using the library. Check for any known security vulnerabilities or reported issues. It is crucial to choose libraries that have a good track record of addressing security concerns promptly. Best practices for using third-party libraries. To make the most of third-party libraries and ensure a smooth integration into your projects, follow these best practices. 1. Research and evaluate. Before integrating a library into your project, thoroughly research and evaluate its features, documentation, and community support. This will help you make an informed decision and avoid potential issues down the line. 2. Keep libraries up to date. Regularly update the libraries you use to benefit from bug fixes, performance improvements, and new features. Staying up to date ensures that you are using the most stable and secure versions of the libraries. 3. Understand the library's API. Take the time to understand the library's API and how to use it effectively. Read the documentation, explore examples, and experiment with the library's features. This will help you leverage the library's capabilities to their fullest extent. 4. Handle dependencies carefully. When using multiple libraries, be mindful of their dependencies. Ensure that the versions of the libraries you choose are compatible with each other to avoid conflicts and compatibility issues. 5. Test thoroughly. Before deploying your application, thoroughly test the integration of the third-party libraries. This includes testing various scenarios, edge cases, and potential conflicts with other parts of your codebase. Testing helps identify and resolve issues early on, ensuring a stable and reliable application. 6. Contribute to the community. If you encounter issues or find ways to improve a library, consider contributing back to the community. This can involve reporting bugs, submitting pull requests, or providing feedback. Contributing helps improve the library for everyone and fosters a collaborative and supportive community. Conclusion. Using third-party libraries is an essential skill for any programmer. They provide a wealth of functionality, save time and effort, and allow you to deliver more robust and feature-rich applications. By understanding the benefits, choosing the right libraries, and following best practices, you can effectively leverage third-party libraries to enhance your programming projects. 6.3 API Documentation and Integration. APIs, application programming interfaces, play a crucial role in modern software development. They allow different software systems to communicate and interact with each other, enabling developers to leverage existing functionality and services without having to reinvent the wheel. In this section, we will explore the importance of API documentation and integration, and discuss best practices for working with APIs effectively. Understanding API documentation. API documentation serves as a guide for developers who want to integrate their applications with a particular API. It provides detailed information about the available endpoints, request and response formats, authentication methods, error handling, and other important aspects of the API. Understanding and following the API documentation is essential for successful integration. When working with API documentation, it is important to pay attention to the following key elements. 1. Endpoints and methods. API documentation typically lists all the available endpoints and the HTTP methods get, post, put, delete, etc. that can be used to interact with them. Each endpoint represents a specific functionality or resource provided by the API. Understanding the purpose and behavior of each endpoint is crucial for building the desired functionality in your application. 2. Request and response formats. API documentation provides information about the expected format of the requests you need to send to the API and the format of the responses you will receive. This includes details about the required headers, query parameters, request bodies, and the structure of the response data. Understanding these formats is essential for correctly constructing requests and processing responses in your application. 3. Authentication and authorization. Many APIs require authentication to ensure that only authorized users can access their resources. API documentation usually explains the authentication methods supported by the API, such as API keys, OAuth, or token-based authentication. It also provides instructions on how to include authentication credentials in your requests. Understanding and implementing the authentication process correctly is crucial for secure and authorized access to the API. 4. Rate limiting and usage policies. APIs often impose rate limits to prevent abuse and ensure fair usage. API documentation usually provides information about the rate limits, including the number of requests allowed per minute or hour, and any additional usage policies. It is important to understand and respect these limits to avoid disruptions in your application's functionality. 5. Error handling and status codes. APIs can encounter errors during processing, and API documentation provides information about the possible error scenarios and the corresponding status codes. Understanding the error codes and their meanings is crucial for handling errors gracefully in your application. The documentation may also provide additional details about error response formats and error message structures. Integrating with APIs. Integrating your application with an API involves making HTTP requests to the API endpoints and processing the responses. Here are some best practices to consider when integrating with APIs. 1. Read and understand the documentation. Before integrating with an API, thoroughly read and understand the API documentation. Pay attention to the details mentioned earlier, such as endpoints, request and response formats, authentication methods, and error handling. Familiarize yourself with the API's capabilities and limitations to ensure a smooth integration process. 2. Use API client libraries. Many APIs provide client libraries in various programming languages to simplify the integration process. These libraries often encapsulate the low-level details of making HTTP requests and handling authentication, allowing you to focus on the core functionality of your application. Utilizing these client libraries can save you time and effort in implementing the integration. 3. Implement error handling. APIs can return errors for various reasons, such as invalid requests, authentication failures, or server-side issues. It is important to implement robust error handling in your application to gracefully handle these scenarios. Refer to the API documentation for the expected error codes and messages, and design your error handling logic accordingly. 4. Implement caching and rate limiting. To improve performance and minimize unnecessary API calls, consider implementing caching mechanisms in your application. Caching allows you to store and reuse API responses for a certain period, reducing the need for frequent requests. Additionally, respect the rate limits imposed by the API to avoid exceeding the allowed usage and potential disruptions in your application. 5. Test and monitor integration. Thoroughly test your integration with the API to ensure that it functions as expected. Test different scenarios, including both successful and error cases, to validate the behavior of your application. Additionally, monitor the integration in production to identify any issues or performance bottlenecks and address them promptly. Conclusion. API documentation is a valuable resource for developers looking to integrate their applications with external services and functionality. Understanding and following the documentation is crucial for successful integration. By carefully reading and understanding the API documentation, using client libraries when available, implementing robust error handling, and testing and monitoring the integration, you can effectively integrate your application with APIs and leverage their capabilities to enhance your software. 6.4 Handling API errors and exceptions. When working with APIs, it is crucial to understand how to handle errors and exceptions that may occur during the integration process. APIs can be unpredictable, and errors can arise due to various reasons such as incorrect input, server issues, or network problems. As a programmer, it is your responsibility to anticipate and handle these errors gracefully to ensure the stability and reliability of your application. Understanding API errors. APIs typically use HTTP status codes to indicate the success or failure of a request. These status codes provide valuable information about the outcome of the request and can help you identify and handle errors effectively. Some common HTTP status codes related to API errors include 200 OK, the request was successful. 400 bad request, the request was malformed or contained invalid parameters. 401 unauthorized, the request requires authentication, and the provided credentials are invalid or missing. 403 forbidden, the server understood the request, but the user does not have permission to access the requested resource. 404 not found, the requested resource could not be found on the server. 500 internal server error, an unexpected error occurred on the server. By understanding these status codes, you can determine the nature of the error and take appropriate action in your code. Handling API errors. When an API error occurs, it is essential to handle it gracefully to provide a good user experience and prevent your application from crashing. Here are some best practices for handling API errors. 1. Check the HTTP status code. Start by checking the HTTP status code returned by the API. This will give you an initial indication of whether the request was successful or if an error occurred. Based on the status code, you can decide how to proceed with error handling. 2. Parse the error response. APIs often provide additional information about the error in the response body. Parse the response to extract relevant error details such as error codes, error messages, or error descriptions. This information can help you understand the cause of the error and provide appropriate feedback to the user. 3. Provide meaningful error messages. When an API error occurs, it is crucial to provide clear and meaningful error messages to the user. Avoid displaying technical error messages directly to the user, as they may not understand them. Instead, translate the error information into user-friendly language and provide instructions on how to resolve the issue if possible. 4. Implement error handling strategies. Depending on the nature of the error, you can implement different error handling strategies. For example, retry. If the error is temporary, such as a network issue, you can retry the request after a short delay. Backoff. If the error persists, implement an exponential backoff strategy to avoid overwhelming the API server with repeated requests. Graceful degradation. If a specific API endpoint is unavailable, you can gracefully degrade the functionality of your application by providing alternative options or fallback mechanisms. 5. Log errors for debugging. Logging errors is essential for debugging and troubleshooting purposes. Implement a logging mechanism to capture and store error information, including the request details, error messages, and timestamps. This will help you identify recurring issues and track down the root cause of errors. 6. Handle exceptions. In addition to API errors, your code may also encounter exceptions during the integration process. Exceptions can occur due to various reasons, such as network failures, invalid responses, or programming errors. It is crucial to handle these exceptions appropriately to prevent your application from crashing. Use try-catch blocks to catch exceptions and handle them gracefully. Within the catch block, you can log the exception details, display an error message to the user, or take any other necessary action to recover from the exception. 7. Provide fallback options. In some cases, an API may not be available or may return unexpected errors. To ensure the smooth functioning of your application, consider providing fallback options or alternative paths when an API error occurs. This can include using cached data, providing default values, or offering alternative features that do not rely on the API. Conclusion. Handling API errors and exceptions is a critical aspect of building robust and reliable applications. By understanding the HTTP status codes, parsing error responses, and implementing appropriate error handling strategies, you can ensure that your application gracefully handles errors and provides a seamless user experience. Remember to log errors for debugging purposes and provide fallback options to mitigate the impact of API errors on your application. 7. Version control and collaboration. 7.1 Introduction to Version Control Systems. Version control systems, VCS, are essential tools for software development teams and individual programmers. They help manage changes to code, track revisions, and facilitate collaboration among team members. In this section, we will explore the basics of version control systems and their importance in the software development process. What is version control? Version control is a system that records changes to a file or set of files over time. It allows developers to track modifications, revert to previous versions, and collaborate with others seamlessly. Version control systems provide a centralized repository where developers can store and manage their codebase. Benefits of version control systems. Using a version control system offers several advantages for programmers and development teams. History and revisions. Version control systems maintain a complete history of changes made to the codebase. This allows developers to review and revert to previous versions if necessary. It also enables them to track who made specific changes and when. Collaboration. Version control systems facilitate collaboration among team members. Multiple developers can work on the same codebase simultaneously, and the system manages merging their changes. It helps prevent conflicts and ensures that everyone is working on the latest version of the code. Branching and merging. Version control systems allow developers to create branches, which are independent lines of development. This feature enables teams to work on different features or bug fixes simultaneously without interfering with each other's work. Branches can later be merged back into the main codebase. Code integrity. Version control systems ensure the integrity of the codebase by preventing accidental overwrites or deletions. Developers can always revert to a previous version if a mistake occurs, minimizing the risk of losing valuable code. Code reviews. Version control systems make it easier to conduct code reviews. Team members can review changes made by others, provide feedback, and suggest improvements. This process helps maintain code quality and ensures that best practices are followed. Backup and recovery. Version control systems act as a backup mechanism for code. Even if a developer's local copy is lost or corrupted, the code can be recovered from the central repository. This feature provides an additional layer of protection against data loss. Types of version control systems. There are two main types of version control systems, centralized and distributed. Centralized version control systems, CVCS. In a centralized version control system, there is a single central repository that stores the entire codebase and its history. Developers check out files from this central repository, make changes locally, and then commit their changes back to the central server. Examples of centralized version control systems include Apache Subversion, SVN, and Perforce. Distributed version control systems, DVCS. Distributed version control systems take a different approach. Instead of relying on a central repository, each developer has a complete copy of the codebase, including its history, on their local machine. Developers can make changes, create branches, and commit their changes locally without needing a network connection. Examples of distributed version control systems include Git, Mercurial, and Bazaar. Why use Git? Git is the most widely used distributed version control system in the software development industry. It offers numerous advantages that make it the preferred choice for many developers and teams. Speed and performance. Git is designed to be fast and efficient, even with large codebases. Operations like committing changes, branching, and merging are typically lightning fast. Branching and merging. Git's branching and merging capabilities are powerful and flexible. Creating branches is quick and easy, allowing developers to experiment and work on different features simultaneously. Merging branches is also straightforward, with built-in tools to handle conflicts. Decentralized workflow. Git's distributed nature allows developers to work offline and commit changes locally. This flexibility is particularly useful for remote teams or situations where a network connection is not always available. Community and ecosystem. Git has a vast and active community of developers, which means there is extensive documentation, tutorials, and support available. Additionally, Git integrates seamlessly with popular development tools and platforms, such as GitHub and GitLab. Industry standard. Git has become the de facto standard for version control in the software development industry. Many companies and open source projects rely on Git for managing their codebase, making it a valuable skill for programmers. Getting started with Git. To start using Git, you need to install it on your computer and set up a repository for your project. There are several resources available online that provide detailed instructions on installing and configuring Git for different operating systems. Once Git is set up, you can initialize a new repository or clone an existing one. Initializing a repository creates a new Git project from scratch, while cloning allows you to create a local copy of an existing repository. After setting up a repository, you can start using Git's commands to manage your codebase. Some common Git commands include git add files or changes to the staging area. Git commit changes to the repository. Git push local changes to a remote repository. Git pull, fetch and merge changes from a remote repository. Git branch, create, list, or delete branches. Git merge changes from one branch into another. These are just a few examples of the many commands available in Git. It's essential to familiarize yourself with Git's commands and workflows to make the most of this powerful version control system. Conclusion. Version control systems are indispensable tools for programmers and development teams. They provide a structured and efficient way to manage code changes, collaborate with others, and maintain the integrity of the codebase. Git, in particular, has become the industry standard due to its speed, flexibility, and extensive community support. By mastering version control systems like Git, you can enhance your productivity, improve collaboration, and become a better programmer. 7.2. Using Git for version control. Version control is an essential tool for any programmer, as it allows you to track changes to your code, collaborate with others, and easily revert to previous versions if needed. Git is one of the most popular version control systems used today, known for its flexibility, speed, and powerful features. In this section, we will explore the basics of using Git for version control and how it can help you become a better programmer. Understanding Git. Git is a distributed version control system that allows multiple developers to work on a project simultaneously. It keeps track of changes made to files and directories, creating a history of commits that can be easily managed and shared. Git operates locally on your computer, which means you can work offline and commit changes to your local repository. Once you are ready, you can push your changes to a remote repository, such as GitHub, to collaborate with others. Setting up Git. Before you can start using Git, you need to install it on your computer and configure it with your name and email address. Git is available for Windows, Mac OS, and Linux, and you can download the installer from the official Git website. Once installed, open a terminal or command prompt and run the following commands to configure your name and email. Git config, global user.name, your name, git config, global user. Email, your.email@example.com. These settings will be used for all your Git repositories, so make sure to use the name and email you want to associate with your commits. Creating a Git repository. To start using Git for version control, you need to initialize a Git repository in your project directory. Open a terminal or command prompt, navigate to your project directory, and run the following command. Git init. This command creates a hidden .git directory that contains all the necessary files and metadata for Git to track changes in your project. You can now start adding files to your repository and making commits. Making commits. A commit in Git represents a snapshot of your project at a specific point in time. It includes all the changes you have made since the last commit, along with a commit message that describes the changes. To make a commit, follow these steps. Stage your changes. Before you can commit your changes, you need to stage them. Staging allows you to select which changes you want to include in the commit. You can stage individual files or entire directories using the git add command. For example, to stage a file named script.js, run the following command. Git add script.js. You can also use wildcards to stage multiple files at once. For example, to stage all JavaScript files in a directory, run git add .js. Commit your changes. Once you have staged your changes, you can commit them. To create a commit, use the git commit command followed by a commit message. The commit message should be concise and descriptive, explaining what changes were made. For example, git commit m, add login functionality. After running this command, Git will create a new commit with your changes in the specified commit message. Viewing commit history. Git provides several commands to view the commit history of your repository. These commands allow you to see the changes made in each commit, who made the changes, and when they were made. Here are some useful commands. Git log displays the commit history in reverse chronological order, showing the commit hash, author, date, and commit message. Git show less than commit hash greater than shows the changes made in a specific commit, including the file differences in the commit message. Git diff less than commit hash -1 greater than less than commit hash -2 greater than shows the differences between two commits, allowing you to compare changes made over time. By using these commands, you can easily navigate through your commit history and understand the evolution of your project. Branching and merging. One of the powerful features of Git is its ability to handle branching and merging. Branching allows you to create separate lines of development, enabling you to work on new features or bug fixes without affecting the main codebase. Merging, on the other hand, allows you to combine the changes from one branch into another. To create a new branch, use the git branch command followed by the branch name. For example, to create a branch named feature login, run git branch feature login. To switch to the new branch, use the git checkout command. Git checkout feature login. Now you can make changes in the feature login branch without affecting the main branch. Once you have completed your changes, you can merge them back into the main branch using the git merge command. Git checkout main git merge feature login. Git will automatically merge the changes from the feature login branch into the main branch, combining the work done in both branches. Collaborating with Git and GitHub. Git is not only a powerful version control system but also a great tool for collaboration. By using Git together with a remote repository hosting service like GitHub, you can easily share your code with others, contribute to open source projects, and work on team projects. To collaborate with others using Git and GitHub, follow these steps. Create a remote repository. Sign up for a GitHub account and create a new repository for your project. Once created, you will get a remote repository URL that you can use to push your local repository to GitHub. Add a remote repository. In your local repository, run the following command to add a remote repository. Git remote add origin less than remote repository URL greater than replace less than remote repository URL greater than with the URL of your remote repository. Push your changes. To push your local repository to the remote repository, use the git push command. Git push u origin main. This command pushes your changes to the main branch of the remote repository. The U flag sets the upstream branch, allowing you to use git pull and git push without specifying the branch in the future. Collaborate with others. Once your code is on GitHub, you can invite others to collaborate on your project by adding them as collaborators. They can clone the repository, make changes, and push their changes back to GitHub. You can then review their changes and merge them into the main branch. Git and GitHub provide many more features for collaboration, such as pull requests, code reviews, and issue tracking. By mastering these tools, you can become a more effective and efficient programmer, working seamlessly with others on projects of any size. Conclusion. Using Git for version control is a fundamental skill for any programmer. It allows you to track changes, collaborate with others, and easily manage your codebase. By understanding the basics of Git and its powerful features, you can become a better programmer and work more efficiently on your projects. 7.3. Collaborating with Git and GitHub. In today's software development landscape, collaboration is a crucial aspect of being a successful programmer. Working together with other developers on a project requires effective communication, coordination, and a reliable version control system. Git and GitHub are two widely used tools that enable programmers to collaborate seamlessly and efficiently. Git is a distributed version control system that allows developers to track changes to their codebase, collaborate with others, and manage different versions of their project. GitHub, on the other hand, is a web-based hosting service that provides a platform for developers to store and share their Git repositories. It offers additional features such as issue tracking, pull requests, and project management tools. Collaborating with Git and GitHub offers several benefits for programmers. 1. Version control. Git provides a robust version control system that allows programmers to track changes to their codebase over time. With Git, you can easily revert to previous versions of your code, compare changes between different versions, and collaborate with others without the fear of losing any work. This ensures that your project remains organized and allows for easy bug tracking and troubleshooting. 2. Branching and merging. One of the key features of Git is its ability to create branches. Branches allow developers to work on different features or bug fixes simultaneously without interfering with each other's code. This promotes parallel development and reduces conflicts. Once a feature or bug fix is complete, it can be merged back into the main codebase using Git's merging capabilities. This makes it easy to manage multiple tasks and collaborate effectively with other team members. 3. Collaboration workflow. Git and GitHub provide a collaborative workflow that streamlines the development process. Developers can create branches for specific tasks, work on them independently, and then submit their changes as pull requests. Pull requests allow other team members to review the code, provide feedback, and suggest changes. This promotes code quality and ensures that all changes are thoroughly reviewed before being merged into the main codebase. 4. Issue tracking and project management. GitHub offers built-in issue tracking and project management tools that help teams stay organized and focused. Issues can be created to track bugs, feature requests, or any other tasks that need to be addressed. Developers can assign issues to themselves or other team members, set priorities, and track progress. This ensures that everyone is on the same page and helps in managing the project effectively. 5. Collaboration beyond code. Git and GitHub are not limited to just code collaboration. They also provide a platform for collaboration beyond code. Developers can use GitHub's wiki feature to create documentation, share knowledge, and collaborate on project-related discussions. Additionally, GitHub's integration with other tools such as continuous integration services and project management platforms further enhances the collaboration experience. To effectively collaborate with Git and GitHub, here are some best practices to follow. 1. Create meaningful commit messages. When committing changes to your Git repository, it is important to provide clear and concise commit messages. A good commit message describes the purpose of the change and provides enough information for others to understand the context. This helps in tracking changes and makes it easier to review and understand the codebase. 2. Use branches for different tasks. Create separate branches for different tasks or features you are working on. This allows you to work independently without interfering with the main codebase. It also makes it easier to track changes and merge them back into the main branch when the task is complete. 3. Regularly pull changes from the main branch. To stay up to date with the latest changes in the project, regularly pull changes from the main branch into your local branch. This ensures that you are working with the most recent codebase and reduces conflicts when merging your changes back into the main branch. 4. Review pull requests thoroughly. When reviewing pull requests from other team members, take the time to thoroughly review the code, provide constructive feedback, and suggest improvements. This helps maintain code quality and ensures that all changes are thoroughly reviewed before being merged. 5. Communicate and collaborate effectively. Effective communication is key to successful collaboration. Use GitHub's built-in communication tools such as issue comments, pull request discussions, and project boards to communicate with your team members. Clearly communicate your ideas, ask questions, and provide feedback in a respectful and constructive manner. 6. Follow code review best practices. When participating in code reviews, follow best practices such as focusing on the code and not the person, providing specific and actionable feedback, and being open to receiving feedback on your own code. Code reviews are an opportunity to learn from each other and improve the overall quality of the codebase. 7. Document and share knowledge. Take advantage of GitHub's wiki feature to create documentation and share knowledge with your team. Documenting important decisions, project guidelines, and common issues helps in maintaining a shared understanding of the project and facilitates onboarding of new team members. Collaborating with Git and GitHub is an essential skill for any programmer. It enables efficient teamwork, promotes code quality, and ensures that projects are managed effectively. By following best practices and leveraging the features offered by Git and GitHub, you can become a better collaborator and enhance your programming skills. 7.4. Branching and merging strategies. In software development, version control systems (VCS) play a crucial role in managing code changes and collaboration among team members. One of the key features of VCS is the ability to create branches, which allow developers to work on different features or bug fixes independently. However, without a proper branching and merging strategy, managing branches can become chaotic and lead to conflicts and code inconsistencies. Understanding branching. Before diving into branching and merging strategies, it's important to understand the concept of branches in version control systems. A branch is essentially a separate line of development that allows developers to work on different features or bug fixes without affecting the main codebase. Each branch has its own commit history, allowing developers to make changes and experiment without impacting the stability of the main codebase. Types of branches. There are several types of branches that you may encounter in a typical software development workflow. Main branch, also known as the master or trunk branch. This is the primary branch that represents the stable and production-ready version of the codebase. It should always be in a deployable state. Feature branch. Feature branches are created when working on a new feature or functionality. These branches are typically short-lived and are merged back into the main branch once the feature is complete. Bug fix branch. Bug fix branches are created to address specific issues or bugs in the codebase. Similar to feature branches, bug fix branches are merged back into the main branch once the bug is resolved. Release branch. Release branches are created when preparing for a new software release. These branches are used to stabilize the codebase and perform any necessary testing before deploying to production. Hotfix branch. Hotfix branches are created to address critical issues or bugs that require immediate attention. These branches are typically created from the main branch, and once the hotfix is complete, they are merged back into both the main branch and any active release branches. Branching and merging strategies. Having a well-defined branching and merging strategy is essential for maintaining code quality, ensuring smooth collaboration, and minimizing conflicts. Here are some commonly used strategies. Feature branch workflow. This strategy involves creating a new branch for each new feature or functionality. Developers work on their respective branches independently and merge them back into the main branch once the feature is complete. This approach allows for parallel development and easy isolation of changes. Gitflow workflow. Gitflow is a popular branching model that provides a structured approach to managing branches. It involves two main branches, the main branch representing the stable codebase, and the develop branch where ongoing development takes place. Feature branches are created from the develop branch, and once complete, they are merged back into the develop branch. Release branches are created from the develop branch to prepare for software releases, and hotfix branches are created from the main branch to address critical issues. Trunk-based development. Trunk-based development is a strategy that promotes frequent integration of changes into the main branch. Developers work directly on the main branch or short-lived feature branches and merge their changes back into the main branch as soon as they are complete. This approach encourages continuous integration and reduces the complexity of managing long-lived branches. Forking workflow. In the forking workflow, each developer creates a personal fork of the main repository. They work on their forked repository, creating branches for features or bug fixes. Once the changes are complete, they submit a pull request to merge their changes back into the main repository. This strategy is commonly used in open-source projects and allows for easy collaboration among contributors. Best practices for branching and merging. To ensure a smooth and efficient branching and merging process, consider the following best practices. Keep branches small and focused. Create branches that are focused on specific features or bug fixes. This helps in isolating changes and reduces the chances of conflicts. Regularly merge changes. Regularly merge changes from the main branch into your feature branches to keep them up to date. This helps in resolving conflicts early and ensures that your changes integrate smoothly with the latest codebase. Perform code reviews. Before merging branches, conduct thorough code reviews to ensure code quality and adherence to coding standards. Code reviews also help in catching potential bugs or issues before they make their way into the main branch. Communicate and coordinate. When working in a team, effective communication and coordination are crucial. Clearly communicate your intentions and progress with other team members to avoid conflicts and duplication of work. Resolve conflicts promptly. Conflicts can arise when merging branches with overlapping changes. It's important to resolve conflicts promptly by carefully reviewing the conflicting code and making necessary adjustments. Regular communication with other team members can help in resolving conflicts efficiently. Use automation tools. Utilize automation tools, such as continuous integration systems, to automate the process of building, testing, and merging branches. These tools can help in detecting issues early and ensure that branches are merged only when all tests pass successfully. By following these best practices and selecting the appropriate branching and merging strategy for your project, you can streamline your development process, improve collaboration, and maintain a stable and reliable codebase. Remember, mastering branching and merging strategies is an essential skill for any programmer working in a team environment. It allows for efficient collaboration, smooth integration of changes, and ensures the stability and quality of the codebase. 8. Writing secure code. To become a better programmer, there are several key areas you can focus on improving. These include mastering the fundamentals of programming, writing clean and readable code, understanding algorithms and data structures, efficient problem-solving techniques, working with APIs and libraries, version control and collaboration, writing secure code, optimizing performance, continuous learning and improvement, working effectively in a team, and career growth and advancement. In this book, we will explore each of these areas in detail, providing practical tips, techniques, and best practices to help you enhance your programming skills. By following the guidance in this book, you will be able to level up your programming abilities and become a more proficient and successful programmer. Let's dive into the content of Section 8.1, Common Security Vulnerabilities. 8.1 Common Security Vulnerabilities. In today's digital landscape, security is of utmost importance. As a programmer, it is crucial to be aware of common security vulnerabilities and understand how to mitigate them. By addressing these vulnerabilities, you can protect your applications and the sensitive data they handle from potential threats and attacks. Cross-site scripting (XSS). Cross-site scripting (XSS) is a vulnerability that allows attackers to inject malicious scripts into web pages viewed by other users. This can lead to the theft of sensitive information, such as login credentials or personal data. To prevent XSS attacks, always validate and sanitize user input, encode output properly, and use security libraries or frameworks that provide built-in protection against XSS. SQL injection. SQL injection is a technique where attackers manipulate user input to execute unauthorized SQL queries. This can result in unauthorized access to databases, data manipulation, or even complete data loss. To prevent SQL injection, use parameterized queries or prepared statements instead of concatenating user input directly into SQL statements. Additionally, implement proper input validation and sanitization to ensure only valid data is passed to the database. Cross-site request forgery (CSRF). Cross-site request forgery (CSRF) is an attack that tricks users into performing unwanted actions on a website without their consent. This can lead to unauthorized changes in user settings, data modification, or even financial transactions. To prevent CSRF attacks, use anti-CSRF tokens, which are unique tokens embedded in forms or requests that validate the authenticity of the request. Additionally, ensure that sensitive actions require explicit user consent or authentication. Insecure Direct Object References (IDOR). Insecure Direct Object References (IDOR) occur when an application exposes internal references to objects, such as database records or files, without proper authorization checks. Attackers can manipulate these references to access unauthorized data or perform actions they shouldn't have access to. To prevent IDOR vulnerabilities, implement proper access controls and authorization checks at both the server and client sides. Avoid exposing internal identifiers or sensitive information in URLs or hidden fields. Cross-site script inclusion (XSSI). Cross-site script inclusion (XSSI) is a vulnerability that allows attackers to include external scripts from malicious sources into a web application. This can lead to the execution of arbitrary code, data theft, or session hijacking. To prevent XSSI attacks, ensure that external scripts are loaded from trusted sources only. Implement Content Security Policy (CSP) headers to restrict the loading of external resources and enforce strict security policies. Security misconfigurations. Security misconfigurations occur when applications or systems are not properly configured, leaving them vulnerable to attacks. This can include default or weak passwords, unnecessary open ports, outdated software, or improper file permissions. To prevent security misconfigurations, follow security best practices, such as regularly updating software, using strong and unique passwords, disabling unnecessary services, and applying the principle of least privilege. Insecure cryptography. Insecure cryptography practices can lead to the compromise of sensitive data. This includes using weak encryption algorithms, improper key management, or storing passwords in plain text. To ensure secure cryptography, use strong encryption algorithms and protocols, properly manage encryption keys, and follow industry-standard practices for password storage, such as using salted hashes and employing key-stretching algorithms. Denial of service (DOS) attacks. Denial of service (DOS) attacks aim to disrupt the availability of a system or application by overwhelming it with excessive requests or resource consumption. This can lead to service downtime, loss of revenue, or reputational damage. To mitigate DOS attacks, implement rate limiting, traffic monitoring, and anomaly detection mechanisms. Additionally, use load balancers and scalable infrastructure to distribute the load and handle increased traffic. These are just a few examples of common security vulnerabilities that programmers should be aware of. By understanding these vulnerabilities and implementing appropriate security measures, you can significantly reduce the risk of security breaches and protect your applications and users' data. In the next section, we will explore input validation and sanitization techniques, which are essential for preventing security vulnerabilities related to user input. 8.2. Input validation and sanitization. In the world of programming, input validation and sanitization are crucial steps in ensuring the security and integrity of your code. By properly validating and sanitizing user input, you can prevent a wide range of security vulnerabilities, such as injection attacks, cross-site scripting (XSS), and cross-site request forgery (CSRF). In this section, we will explore the importance of input validation and sanitization and discuss best practices for implementing them in your code. The importance of input validation. Input validation is the process of verifying that the data entered by the user meets the expected format and constraints. It is essential to validate user input to prevent malicious or erroneous data from compromising the security and functionality of your application. Without proper input validation, attackers can exploit vulnerabilities in your code and execute unauthorized actions or gain unauthorized access to sensitive information. One common type of attack that can be prevented through input validation is SQL injection. SQL injection occurs when an attacker inserts malicious SQL code into a query, tricking the application into executing unintended commands. By validating and sanitizing user input, you can ensure that any user-supplied data is properly escaped or parameterized before being used in database queries, effectively mitigating the risk of SQL injection attacks. Another common vulnerability that can be prevented through input validation is cross-site scripting (XSS). XSS attacks occur when an attacker injects malicious scripts into web pages viewed by other users. By validating and sanitizing user input, you can ensure that any user-supplied data is properly encoded or escaped before being displayed on a web page, preventing the execution of malicious scripts. Best practices for input validation. To effectively validate user input, consider the following best practices. Define clear validation rules. Clearly define the expected format and constraints for each input field. This includes specifying the allowed characters, length limits, and any specific patterns or formats required. Validate on both client and server side. Implement validation checks on both the client side, using JavaScript, and the server side, using your programming language of choice. Client-side validation provides immediate feedback to the user, while server-side validation ensures that no malicious data bypasses the client-side checks. Use secure validation libraries. Utilize well-established and secure validation libraries provided by your programming language or framework. These libraries often have built-in functions for validating common types of input, such as email addresses, URLs, and numeric values. Avoid relying solely on client-side validation. Client-side validation can be easily bypassed by attackers. Always perform server-side validation to ensure the integrity of the data. Sanitize user input. In addition to validation, it is crucial to sanitize user input to remove any potentially harmful or unwanted characters. Sanitization involves removing or escaping characters that could be used to exploit vulnerabilities in your code. Implement input filtering. Implement input filtering techniques to remove or neutralize potentially dangerous characters or sequences. This can include techniques such as whitelisting, blacklisting, or using regular expressions to match and remove or replace specific patterns. Use parameterized queries. When interacting with databases, use parameterized queries or prepared statements to ensure that user-supplied data is properly escaped or encoded. This prevents SQL injection attacks by separating the query logic from the user input. Implement CAPTCHA or reCAPTCHA. To prevent automated attacks, consider implementing CAPTCHA or reCAPTCHA mechanisms to verify that the user is human. This can help protect against brute force attacks and reduce the risk of unauthorized access. By following these best practices, you can significantly reduce the risk of security vulnerabilities resulting from improper input validation and sanitization. Conclusion. Input validation and sanitization are critical steps in writing secure code. By properly validating and sanitizing user input, you can prevent a wide range of security vulnerabilities and protect your application from malicious attacks. Remember to define clear validation rules, validate on both client and server side, use secure validation libraries, and implement input filtering and parameterized queries. By incorporating these best practices into your development process, you can enhance the security and integrity of your code. 8.3 Authentication and authorization. Authentication and authorization are crucial aspects of building secure and reliable software applications. In this section, we will explore the concepts of authentication and authorization, their importance in software development, and best practices for implementing them in your projects. Understanding authentication. Authentication is the process of verifying the identity of a user or system. It ensures that the user or system is who they claim to be before granting access to resources or functionalities. Authentication is typically achieved through the use of credentials, such as usernames and passwords, tokens, or digital certificates. User authentication. User authentication is the most common form of authentication in software applications. It involves verifying the identity of individual users who are accessing the system. User authentication can be implemented using various methods, including username and password. This is the traditional method where users provide a unique username and a secret password to authenticate themselves. It is essential to enforce strong password policies and store passwords securely, such as using hashing algorithms and salting techniques. Multi-factor authentication (MFA). MFA adds an extra layer of security by requiring users to provide multiple forms of identification. This can include something the user knows password, something the user has, smartphone or hardware token, or something the user is biometric data like fingerprints or facial recognition. Single sign-on (SSO). SSO allows users to authenticate once and gain access to multiple applications or systems without the need to re-enter their credentials. It simplifies the authentication process for users and improves overall user experience. System authentication. In addition to user authentication, systems themselves may require authentication to interact with other systems or services. This is commonly seen in API integrations or microservices architectures. System authentication can be achieved using methods such as API keys. API keys are unique identifiers that are used to authenticate and authorize requests made by systems or applications. They are typically generated by the system and provided to authorized clients. API keys should be kept confidential and rotated periodically to maintain security. Digital certificates. Digital certificates are used to authenticate the identity of systems or applications. They are issued by trusted certificate authorities and contain information about the system or application, including a public key. Digital certificates are commonly used in secure communication protocols like HTTPS. Understanding authorization. Authorization is the process of granting or denying access to specific resources or functionalities based on the authenticated user's privileges. It ensures that users can only access the resources they are authorized to use. Authorization is typically implemented using access control mechanisms. Role-based access control (RBAC). Role-based access control (RBAC) is a widely used access control model that assigns permissions to users based on their roles within an organization or system. RBAC simplifies the management of access control by grouping users into roles and assigning permissions to those roles. This allows for easier administration and scalability. In RBAC, users are assigned one or more roles, and each role is associated with a set of permissions. When a user attempts to access a resource or perform an action, the system checks if the user's role has the necessary permissions. If the user has the required permissions, access is granted, otherwise, access is denied. Attribute-based access control (ABAC). Attribute-based access control (ABAC) is an access control model that considers various attributes or characteristics of the user, resource, and environment to make access control decisions. ABAC evaluates attributes such as user roles, user attributes, resource attributes, and environmental conditions to determine access rights. ABAC provides more fine-grained control over access control decisions compared to RBAC. It allows for dynamic and context-aware access control policies. For example, an ABAC policy can grant access to a resource only if the user is in a specific location or during a specific time period. Access control lists (ACLs). Access control lists (ACLs) are a mechanism for defining and managing access control at a granular level. ACLs specify which users or groups have permissions to perform specific actions on a resource. ACLs can be applied to files, directories, databases, or any other resource that requires access control. ACLs can be configured to allow or deny specific actions, such as read, write, or execute, for individual users or groups. They provide a flexible way to control access to resources based on specific requirements. Best practices for authentication and authorization. Implementing robust authentication and authorization mechanisms is crucial for building secure applications. Here are some best practices to consider. Use secure authentication methods. Implement strong password policies, enforce multi-factor authentication where appropriate, and consider using secure protocols like HTTPS for transmitting credentials. Implement secure session management. Use secure session management techniques to protect user sessions from session hijacking or session fixation attacks. This includes using secure session tokens, setting session timeouts, and properly handling session invalidation. Implement least privilege principle. Follow the principle of least privilege when assigning permissions to users or roles. Only grant the minimum set of permissions required for users to perform their tasks. Regularly review and update access control policies. Periodically review and update access control policies to ensure they align with the changing requirements of your application. Remove unnecessary privileges and regularly audit access logs for any suspicious activities. Protect sensitive data. Implement encryption techniques to protect sensitive data, both in transit and at rest. Use secure storage mechanisms and follow industry best practices for data protection. Regularly test and audit your authentication and authorization mechanisms. Perform regular security assessments, penetration testing, and code reviews to identify and address any vulnerabilities in your authentication and authorization implementation. By following these best practices, you can enhance the security and reliability of your applications, ensuring that only authorized users have access to the appropriate resources and functionalities. 8.4. Secure data storage and encryption. In today's digital age, data security is of utmost importance. As a programmer, it is crucial to understand how to securely store and protect sensitive data. This includes personal information, passwords, financial data, and any other confidential information that your application may handle. In this section, we will explore the best practices for secure data storage and encryption. Understanding the importance of secure data storage. Data breaches and unauthorized access to sensitive information can have severe consequences for individuals and organizations. It can lead to identity theft, financial loss, legal issues, and damage to reputation. Therefore, it is essential to implement robust security measures to protect data at rest, stored data, and in-transit data being transmitted between systems. Choosing the right data storage mechanism. When it comes to storing data securely, it is crucial to choose the appropriate data storage mechanism. Different types of data require different levels of security. Here are some common data storage options and their security considerations. Databases. Relational databases, such as MySQL or PostgreSQL, offer built-in security features like access control, encryption, and auditing. It is essential to configure the database properly, enforce strong passwords, and limit access privileges to prevent unauthorized access. File systems. When storing files, it is crucial to ensure that the file system is secure. This includes setting appropriate file permissions, encrypting sensitive files, and regularly monitoring and patching any vulnerabilities in the file system. Cloud storage. If you are using cloud storage services like Amazon S3 or Google Cloud Storage, make sure to enable encryption at rest. Additionally, carefully manage access control and permissions to prevent unauthorized access to your data. Caching mechanisms. Caching data can improve performance, but it also introduces security risks. Ensure that sensitive data is not cached or implement encryption mechanisms to protect cached data. Encryption techniques for data security. Encryption is a fundamental technique for securing data. It involves converting plain text data into an unreadable format, ciphertext, using an encryption algorithm and a secret key. Only authorized parties with the correct key can decrypt the ciphertext and access the original data. Here are some encryption techniques commonly used for secure data storage. Symmetric encryption. In symmetric encryption, the same key is used for both encryption and decryption. It is fast and efficient but requires securely sharing the key between the sender and receiver. Asymmetric encryption. Asymmetric encryption uses a pair of keys, a public key for encryption and a private key for decryption. This eliminates the need to share a secret key but is computationally more expensive. Hashing. Hashing is a one-way encryption technique that converts data into a fixed-length string of characters. It is commonly used for password storage. When a user enters their password, it is hashed and compared with the stored hash value for authentication. Transport Layer Security (TLS). TLS is a protocol that provides secure communication over the Internet. It encrypts data during transmission, ensuring confidentiality and integrity. It is commonly used for securing web applications and APIs. Best practices for secure data storage. To ensure secure data storage, consider the following best practices. Use strong encryption. Always use strong encryption algorithms and keep them up to date. Avoid using weak or deprecated encryption algorithms that can be easily compromised. Protect encryption keys. Safeguard encryption keys by storing them securely. Use hardware security modules (HSMs) or key management systems to protect keys from unauthorized access. Implement access controls. Enforce strict access controls to limit who can access sensitive data. Use role-based access control (RBAC) and least privilege principles to ensure that only authorized individuals can access specific data. Regularly update and patch. Keep your data storage systems and encryption libraries up to date. Regularly apply security patches and updates to protect against known vulnerabilities. Secure data in transit. Implement secure communication protocols like TLS to protect data during transmission. Avoid transmitting sensitive data over unsecured channels. Secure password storage. Hash passwords using strong hashing algorithms like bcrypt or Argon2. Additionally, use techniques like salting to add an extra layer of security. Regularly audit and monitor. Implement logging and monitoring mechanisms to detect any unauthorized access attempts or suspicious activities. Regularly review logs and audit trails to identify and respond to security incidents promptly. By following these best practices, you can significantly enhance the security of your data storage and protect sensitive information from unauthorized access. Conclusion. Secure data storage and encryption are essential aspects of writing secure code. By understanding the importance of secure data storage, choosing the right data storage mechanism, implementing encryption techniques, and following best practices, you can ensure the confidentiality and integrity of sensitive data. Remember, data security is an ongoing process, and it is crucial to stay updated with the latest security practices and technologies to protect against emerging threats. 9. Optimizing performance. 9.1 Identifying performance bottlenecks. Performance is a critical aspect of software development. As a programmer, it is essential to understand how to identify and address performance bottlenecks in your code. Performance bottlenecks are areas of your code that significantly impact the overall speed and efficiency of your program. By identifying and optimizing these bottlenecks, you can improve the performance of your software and provide a better user experience. Understanding performance bottlenecks. Performance bottlenecks can occur in various parts of your code, including algorithms, data structures, memory management, and I/O operations. Identifying these bottlenecks requires a systematic approach and a deep understanding of your codebase. One common performance bottleneck is inefficient algorithms. Algorithms with high time complexity, such as O(n squared or O(n), can cause your program to slow down significantly as the input size increases. Identifying these algorithms and replacing them with more efficient alternatives, such as O(n log n or O(n), can greatly improve the overall performance of your code. Another common bottleneck is inefficient data structures. Using the wrong data structure for a particular task can lead to poor performance. For example, using a linear search on an unsorted array instead of a binary search on a sorted array can result in slower execution times. By choosing the appropriate data structure for your specific needs, you can optimize the performance of your code. Memory management is another area where performance bottlenecks can occur. Inefficient memory allocation and deallocation can lead to memory leaks or excessive memory usage, which can degrade the performance of your program. Identifying and fixing these memory-related issues, such as freeing unused memory or using memory pools, can help improve the overall performance of your code. I/O operations, such as reading from or writing to files or databases, can also be a source of performance bottlenecks. Inefficient I/O operations, such as reading or writing data in small chunks instead of larger batches, can significantly impact the performance of your program. Optimizing these operations, such as using buffered I/O or asynchronous I/O, can help improve the overall performance of your code. Profiling your code. Profiling is a technique used to measure the performance of your code and identify areas that need optimization. By profiling your code, you can gather valuable information about the execution time, memory usage, and function call hierarchy of your program. There are various profiling tools available that can help you identify performance bottlenecks in your code. These tools provide detailed reports and visualizations that highlight areas of your code that consume the most resources or take the longest to execute. One popular profiling tool is the Python Profiler. It allows you to measure the execution time of each function in your code and identify functions that consume a significant amount of CPU time. By analyzing the profiler's output, you can pinpoint functions that need optimization and focus your efforts on improving their performance. Another useful profiling tool is the Memory Profiler. It helps you identify memory-related issues in your code, such as memory leaks or excessive memory usage. By analyzing the Memory Profiler's output, you can identify functions or data structures that consume a large amount of memory and optimize them to improve the overall performance of your code. Benchmarking your code. Benchmarking is another technique that can help you identify performance bottlenecks in your code. Unlike profiling, which focuses on measuring the performance of individual functions, benchmarking measures the overall performance of your program under different scenarios or workloads. To benchmark your code, you need to create representative test cases that simulate real-world usage scenarios. These test cases should cover a wide range of inputs and edge cases to ensure that your code performs well in different situations. There are several benchmarking tools available that can help you automate the process of running and analyzing benchmarks. These tools provide statistical analysis and visualizations that allow you to compare the performance of different versions of your code or different algorithms or data structures. One popular benchmarking tool is Apache JMeter. It is a Java-based tool that allows you to simulate heavy loads on your application and measure its performance under different scenarios. By analyzing the benchmark results, you can identify areas of your code that need optimization and make informed decisions about improving its performance. Analyzing performance metrics. Analyzing performance metrics is an essential step in identifying performance bottlenecks. Performance metrics provide quantitative data about the performance of your code, such as execution time, memory usage, or I/O throughput. When analyzing performance metrics, it is crucial to establish a baseline or a set of performance goals. These goals can be specific targets, such as reducing the execution time by 50% or improving the memory usage by 20%. By comparing the performance metrics against these goals, you can determine whether your code meets the desired performance criteria. There are several key performance metrics that you should consider when analyzing the performance of your code. Execution time, the time it takes for your code to complete its execution. This metric is often the most critical indicator of performance and should be minimized as much as possible. Memory usage, the amount of memory your code consumes during its execution. Excessive memory usage can lead to performance degradation and should be optimized. CPU usage, the percentage of CPU resources your code consumes during its execution. High CPU usage can indicate inefficient algorithms or excessive computational tasks. I/O throughput, the rate at which your code reads from or writes to external resources, such as files or databases. Low I/O throughput can indicate inefficient I/O operations that need optimization. By analyzing these performance metrics and comparing them against your performance goals, you can identify areas of your code that need optimization and prioritize your efforts accordingly. Conclusion. Identifying performance bottlenecks is a crucial skill for any programmer. By understanding the common areas where bottlenecks occur and using profiling, benchmarking, and performance metrics analysis techniques, you can effectively identify and address performance issues in your code. Optimizing the performance of your software not only improves the user experience but also demonstrates your expertise as a programmer. 9.2. Memory management and optimization. Memory management is a critical aspect of programming that can greatly impact the performance and efficiency of your code. As a programmer, it is essential to understand how memory is allocated and deallocated in order to optimize your programs and avoid memory-related issues such as memory leaks and excessive memory usage. Understanding memory management. In most programming languages, memory is divided into two main areas, the stack and the heap. The stack is used for storing local variables and function call information, while the heap is used for dynamically allocating memory. When you declare a variable in your code, the memory for that variable is allocated on the stack. The memory is automatically deallocated when the variable goes out of scope. This automatic memory management is known as stack allocation and is generally fast and efficient. On the other hand, when you dynamically allocate memory using functions like malloc or new, the memory is allocated on the heap. It is your responsibility as a programmer to deallocate this memory when it is no longer needed using functions like free or delete. Failure to deallocate memory can lead to memory leaks, where memory is allocated but never freed, resulting in a loss of available memory. Best practices for memory management. To optimize memory usage and avoid memory-related issues, here are some best practices to follow. Allocate memory only when necessary. Avoid unnecessary memory allocations by allocating memory only when it is required. This helps reduce memory usage and improves performance. Free memory when no longer needed. Always remember to deallocate memory when it is no longer needed. This ensures that the memory is released and can be reused by other parts of your program. Avoid memory leaks. Be cautious when using dynamic memory allocation. Make sure to free the allocated memory before exiting a function or program to prevent memory leaks. Use stack allocation when possible. Whenever possible, use stack allocation instead of dynamic memory allocation. Stack allocation is generally faster and more efficient. Avoid excessive memory allocation. Be mindful of excessive memory allocation, especially in loops or recursive functions. Allocating and deallocating memory frequently can impact performance. Consider reusing memory or using data structures that minimize memory allocation, such as arrays or linked lists. Use data structures wisely. Choose appropriate data structures that optimize memory usage. For example, if you need a collection of fixed-size elements, consider using an array instead of a linked list, as arrays have a smaller memory overhead. Avoid fragmentation. Fragmentation occurs when memory becomes divided into small, non-contiguous blocks, making it difficult to allocate large blocks of memory. To avoid fragmentation, consider using memory allocation techniques like memory pooling or object pooling. Be mindful of pointers. Pointers can be powerful tools but can also introduce memory-related issues if not used correctly. Be careful when dereferencing pointers and ensure they are pointing to valid memory locations. Use memory profiling tools. Memory profiling tools can help identify memory leaks, excessive memory usage, and other memory-related issues. Use these tools to analyze and optimize your code's memory usage. Consider language-specific memory optimization techniques. Different programming languages have their own memory optimization techniques. Familiarize yourself with the memory management features and best practices specific to the language you are using. By following these best practices, you can effectively manage memory in your programs, optimize memory usage, and improve overall performance. Conclusion. Memory management plays a crucial role in optimizing the performance of your programs. Understanding how memory is allocated and deallocated, and following best practices for memory management, can help you avoid memory-related issues and improve the efficiency of your code. By optimizing memory usage, you can create programs that are faster, more reliable, and consume fewer system resources. To become a better programmer, there are several key areas you can focus on to improve your skills and enhance your programming abilities. These areas include mastering the fundamentals, writing clean and readable code, understanding algorithms and data structures, efficient problem solving, working with APIs and libraries, version control and collaboration, writing secure code, optimizing performance, continuous learning and improvement, working effectively in a team, and career growth and advancement. In this section, we will explore code profiling and optimization techniques. Code profiling is the process of analyzing your code's performance to identify bottlenecks and areas for improvement. Optimization techniques involve making changes to your code to enhance its efficiency and speed. By understanding how to profile and optimize your code, you can create programs that run faster and consume fewer resources. Understanding code profiling. Code profiling involves analyzing your code's execution to identify areas that are consuming excessive time or resources. Profiling helps you understand which parts of your code are causing performance issues, allowing you to focus your optimization efforts effectively. There are various profiling techniques available, including time profiling. This technique measures the time taken by each function or section of code to execute. It helps identify functions that are taking longer than expected and can be optimized. Memory profiling. Memory profiling tracks the memory usage of your program, helping you identify memory leaks or excessive memory consumption. By analyzing memory usage patterns, you can optimize your code to reduce memory overhead. CPU profiling. CPU profiling measures the CPU usage of your program, identifying functions or sections of code that are consuming excessive CPU resources. This information can help you optimize your code to reduce CPU usage and improve overall performance. I/O profiling. I/O profiling focuses on analyzing input-output operations, such as file or network operations. By identifying I/O bottlenecks, you can optimize your code to minimize unnecessary I/O operations and improve performance. Profiling tools. To perform code profiling, you can use various profiling tools and libraries available for different programming languages. Some popular profiling tools include Python. For Python, you can use tools like cprofile, line_profiler, and memory_profiler to profile your code and identify performance bottlenecks. Java. Java provides tools like Java Visual VM, JProfiler, and your Kit Java Profiler for profiling Java applications. These tools offer detailed insights into CPU, memory, and thread usage. C++. Profiling C++ code can be done using tools like Valgrind, gprofessor, and Intel vTune. These tools provide detailed information about memory usage, CPU time, and function call graphs. JavaScript. JavaScript developers can use browser developer tools like Chrome DevTools or Firefox developer tools to profile their code. These tools offer insights into CPU usage, memory consumption, and network activity. Other languages. Profiling tools exist for other programming languages as well. It's recommended to explore the specific tools available for your chosen language. Optimization techniques. Once you have identified the performance bottlenecks in your code through profiling, you can apply optimization techniques to improve its efficiency. Here are some common optimization techniques. Algorithmic optimization. Analyze your algorithms and data structures to ensure they are the most efficient for the task at hand. Consider alternative algorithms or data structures that may provide better performance. Loop optimization. Optimize loops by minimizing unnecessary iterations, reducing function calls within loops, and using efficient loop constructs like loop unrolling or loop fusion. Memory optimization. Optimize memory usage by reducing unnecessary allocations, reusing objects or variables, and minimizing memory fragmentation. Consider using data structures that are more memory efficient for your specific use case. Parallelization. Utilize parallel processing techniques, such as multi-threading or distributed computing, to divide tasks and execute them concurrently. This can significantly improve performance on multi-core systems. Caching. Implement caching mechanisms to store frequently accessed data or expensive computations. Caching can reduce the need for repetitive calculations and improve overall performance. Database optimization. Optimize database queries by ensuring proper indexing, minimizing unnecessary joins or subqueries, and optimizing data retrieval and storage strategies. Code refactoring. Refactor your code to improve its readability, maintainability, and performance. Simplify complex code, eliminate redundant operations, and modularize your codebase for better organization. Remember, optimization should be done based on profiling results and actual performance measurements. Premature optimization without proper profiling can lead to unnecessary complexity and reduced code maintainability. Conclusion. Code profiling and optimization techniques are essential skills for any programmer looking to improve their code's performance. By understanding how to profile your code and apply optimization techniques, you can create programs that run faster, consume fewer resources, and provide a better user experience. Remember to always measure the impact of your optimizations and prioritize based on the most significant performance bottlenecks. 9.4 Caching and database optimization. In today's fast-paced digital world, performance is a crucial aspect of any software application. As a programmer, it is essential to optimize your code and make it as efficient as possible. One area where you can significantly improve performance is through caching and database optimization. Understanding caching. Caching is the process of storing frequently accessed data in a temporary storage location, such as memory, to reduce the time it takes to retrieve that data from its original source. By caching data, you can avoid repetitive and time-consuming operations, resulting in faster response times and improved overall performance. Types of caching. There are several types of caching techniques that you can employ in your applications. In-memory caching. This type of caching stores data directly in the application's memory. It is the fastest form of caching as it eliminates the need to access external resources. In-memory caching is ideal for storing frequently accessed data that doesn't change frequently, such as configuration settings or reference data. Database caching. In this approach, you cache the results of database queries to avoid hitting the database repeatedly. By storing the query results in memory, you can quickly retrieve the data when needed, reducing the load on the database server. Page caching. Page caching involves storing the entire HTML output of a web page in memory or on disk. This technique is useful for static pages that don't change frequently. By serving the cached page instead of generating it dynamically, you can significantly reduce the processing time and server load. Object caching. Object caching involves storing the results of expensive operations or complex calculations in memory. By caching the computed objects, you can avoid repeating the calculations, resulting in faster execution times. Implementing caching. To implement caching effectively, you need to consider the following factors. Cache invalidation. When data changes, you need to ensure that the cached version is updated accordingly. Implementing a mechanism to invalidate or refresh the cache when data changes is crucial to maintain data consistency. Cache expiration. Caches should have an expiration mechanism to ensure that stale data is not served to users. Setting an appropriate expiration time based on the data's volatility is essential to strike a balance between performance and data freshness. Cache size. Caches consume memory, so it's important to manage the cache size effectively. Implementing a cache eviction policy, such as LRU least recently used or LFU least frequently used, can help remove less frequently accessed data from the cache to make room for new entries. Cache consistency. In distributed systems, maintaining cache consistency across multiple instances can be challenging. Techniques like cache invalidation broadcasts or using a distributed cache system can help ensure data consistency across different nodes. Database optimization. Databases play a critical role in most software applications, and optimizing database performance can have a significant impact on overall application performance. Here are some techniques to optimize database operations. 1. Indexing. Indexes are data structures that improve the speed of data retrieval operations on database tables. By creating indexes on frequently queried columns, you can reduce the time it takes to search for specific data. However, it's important to strike a balance between the number of indexes and the overhead they introduce during data modification operations. 2. Query optimization. Writing efficient database queries is crucial for optimal performance. Ensure that your queries are properly structured, use appropriate join conditions, and retrieve only the necessary data. Analyze query execution plans and use database-specific tools to identify and optimize slow-performing queries. 3. Denormalization. In some cases, denormalizing the database schema can improve performance. Denormalization involves duplicating data or introducing redundant columns to eliminate the need for complex joins or expensive calculations. However, denormalization should be used judiciously, considering the trade-off between performance gains and data consistency. 4. Database connection management. Establishing and managing database connections can impact performance. Use connection pooling techniques to reuse existing connections instead of creating new ones for each request. Additionally, ensure that connections are properly closed after use to avoid resource leaks. 5. Database partitioning. Partitioning involves dividing large database tables into smaller, more manageable partitions based on specific criteria, such as range or list. Partitioning can improve query performance by reducing the amount of data that needs to be scanned. It also enables better data management and maintenance. 6. Database maintenance. Regular database maintenance tasks, such as index rebuilding, statistics updates, and data purging, can help optimize database performance. Schedule these tasks during off-peak hours to minimize the impact on application availability. 7. Database caching. As mentioned earlier, caching can also be applied at the database level. Database caching involves storing frequently accessed query results in memory to avoid hitting the disk for every request. This can significantly improve query response times and reduce the load on the database server. By implementing these caching and database optimization techniques, you can greatly enhance the performance of your applications. Remember to analyze and measure the impact of these optimizations to ensure they are effective and provide the desired performance improvements. 10. Continuous learning and improvement. 10.1 Keeping up with technology trends. In the rapidly evolving field of programming, it is crucial for programmers to stay up to date with the latest technology trends. As new programming languages, frameworks, and tools emerge, it is essential to continuously learn and adapt to remain competitive and improve your skills as a programmer. This section will provide you with strategies and resources to help you keep up with technology trends. The importance of keeping up with technology trends. Technology is constantly evolving, and as a programmer, it is essential to stay current with the latest trends. Here are a few reasons why keeping up with technology trends is important. Enhanced employability. Employers value programmers who are knowledgeable about the latest technologies. By staying up to date, you increase your chances of finding new job opportunities and advancing in your career. Improved efficiency. New technologies often bring advancements in productivity and efficiency. By staying informed, you can leverage these technologies to streamline your development process and deliver high-quality code more efficiently. Expanded skill set. Learning new technologies broadens your skill set and makes you a more versatile programmer. This allows you to tackle a wider range of projects and increases your value as a professional. Staying relevant. Technology trends shape the industry, and by keeping up with them, you ensure that your knowledge and skills remain relevant. This helps you stay ahead of the competition and positions you as a valuable asset to your team or organization. Strategies for keeping up with technology trends. Keeping up with technology trends can seem overwhelming, but with the right strategies, you can stay informed without feeling overwhelmed. Here are some effective strategies to help you keep up with the ever-changing world of programming. 1. Follow industry blogs and websites. One of the easiest ways to stay informed about technology trends is by following industry blogs and websites. Many reputable websites and blogs regularly publish articles and updates on the latest programming languages, frameworks, and tools. Some popular websites to consider include TechCrunch, provides news and analysis on the latest technology trends. Medium, a platform where experts share their insights and experiences in various programming fields. Stack Overflow blog, offers articles on programming best practices, new technologies, and industry trends. Hacker News, a community-driven website that features news and discussions on technology-related topics. By regularly reading these blogs and websites, you can stay informed about the latest developments in the programming world. 2. Engage in online communities and forums. Participating in online communities and forums is an excellent way to connect with other programmers and stay updated on technology trends. Websites like Reddit and Quora have dedicated communities where programmers discuss the latest technologies, share resources, and ask questions. Joining these communities allows you to learn from others, gain insights, and stay informed about emerging trends. 3. Subscribe to newsletters and podcasts. Newsletters and podcasts are valuable resources for staying up to date with technology trends. Many industry experts and organizations offer newsletters that deliver curated content directly to your inbox. Podcasts, on the other hand, provide an audio format where you can listen to discussions and interviews with industry leaders. Some popular newsletters and podcasts for programmers include Software Engineering Daily, a podcast that covers a wide range of programming topics and trends. JavaScript Weekly, a newsletter that focuses on JavaScript-related news, frameworks, and libraries. Python Bytes, a podcast that discusses the latest trends and news in the Python programming language. Subscribing to newsletters and podcasts allows you to consume information conveniently and stay informed while on the go. 4. Attend webinars and online courses. Webinars and online courses offer a structured learning experience and are an excellent way to stay updated on technology trends. Many organizations and platforms offer webinars and courses on various programming topics. These resources often cover the latest technologies and provide hands-on learning opportunities. By attending webinars and taking online courses, you can deepen your knowledge and stay current with the latest trends. 5. Join professional networks and meetups. Joining professional networks and attending meetups is a great way to connect with other programmers and stay informed about technology trends. Platforms like LinkedIn and Meetup allow you to join professional groups and attend events related to your programming interests. These networks provide opportunities to network, learn from industry experts, and stay updated on the latest trends through discussions and presentations. 6. Experiment with new technologies. To truly understand and keep up with technology trends, it is essential to get hands-on experience with new technologies. Set aside time to experiment with new programming languages, frameworks, or tools. Building small projects or prototypes using these technologies will not only enhance your skills but also give you a practical understanding of their capabilities and potential applications. 7. Follow thought leaders on social media. Social media platforms like Twitter and LinkedIn are excellent sources for staying updated on technology trends. Follow influential programmers, industry leaders, and organizations in your field of interest. These thought leaders often share valuable insights, articles, and updates on the latest technologies. Engaging with their content and participating in discussions can help you stay informed and expand your knowledge. Conclusion. Keeping up with technology trends is crucial for every programmer who wants to stay relevant and continuously improve their skills. By following industry blogs, engaging in online communities, subscribing to newsletters, attending webinars, joining professional networks, experimenting with new technologies, and following thought leaders on social media, you can stay informed and adapt to the ever-changing programming landscape. Embrace the mindset of continuous learning and make staying updated with technology trends a regular part of your professional development. To become a better programmer, there are several key areas you can focus on. These include mastering the fundamentals of programming, writing clean and readable code, understanding algorithms and data structures, efficient problem-solving techniques, working with APIs and libraries, version control and collaboration, writing secure code, optimizing performance, continuous learning and improvement, working effectively in a team, and career growth and advancement. In this section, we will explore the importance of reading and understanding documentation. Documentation plays a crucial role in the software development process as it provides valuable information about the code, libraries, frameworks, and APIs that you are working with. It serves as a guide to help you understand how to use and interact with different components of a system effectively. Why documentation matters. Documentation is essential for several reasons. First and foremost, it helps you understand how to use a particular tool or technology correctly. Whether you are working with a programming language, a library, or an API, documentation provides detailed explanations, examples, and usage guidelines that can save you a significant amount of time and effort. It allows you to leverage the knowledge and experience of others who have already worked on the technology. Secondly, documentation helps you troubleshoot issues and solve problems more efficiently. When you encounter an error or unexpected behavior, referring to the documentation can provide insights into the possible causes and solutions. It often includes troubleshooting guides, FAQs, and known issues that can help you overcome obstacles and avoid common pitfalls. Furthermore, documentation promotes code maintainability and collaboration. When you work on a project with other developers, clear and comprehensive documentation ensures that everyone understands how different components of the system work together. It serves as a reference point for developers to understand the purpose, functionality, and usage of various code modules. This shared understanding improves collaboration, reduces misunderstandings, and facilitates smoother integration of different parts of the system. Types of documentation. Documentation comes in various forms, each serving a specific purpose. Let's explore some common types of documentation you may encounter. API documentation. API documentation provides information about how to interact with a specific application programming interface (API). It includes details about available endpoints, request and response formats, authentication methods, error handling, and usage examples. API documentation is crucial for developers who want to integrate their applications with external services or build upon existing functionality. Language documentation. Language documentation provides a comprehensive overview of a programming language's syntax, features, and standard libraries. It covers topics such as data types, control structures, functions, classes, and modules. Language documentation is an invaluable resource for both beginners and experienced programmers, as it helps them understand the language's capabilities and best practices. Library framework documentation. Library or framework documentation focuses on a specific software library or framework. It explains how to use the library's functions, classes, and modules effectively. It often includes code examples, usage guidelines, and explanations of the library's design principles. Library documentation is essential for developers who want to leverage the functionality provided by third-party libraries to enhance their applications. Code documentation. Code documentation refers to comments and annotations within the code itself. It explains the purpose, functionality, and usage of specific code blocks, functions, or classes. Code documentation helps developers understand the codebase and its internal workings. It is particularly useful when working on large projects or collaborating with other developers. Tips for reading and understanding documentation. Reading and understanding documentation effectively requires a systematic approach. Here are some tips to help you make the most out of the documentation you encounter. Start with an overview. Begin by reading the documentation's overview or introduction section. This provides a high-level understanding of the technology, its purpose, and its key features. It sets the context for the rest of the documentation and helps you grasp the big picture. Follow tutorials and examples. Many documentation resources include tutorials or examples that demonstrate how to use the technology in practice. Following these tutorials can give you hands-on experience and help you understand the concepts more effectively. Try to replicate the examples and experiment with them to deepen your understanding. Refer to the API reference. When working with APIs or libraries, the API reference section is your go-to resource. It provides detailed information about the available functions, classes, and methods, along with their parameters and return values. Pay attention to the expected data types, possible exceptions, and any special considerations mentioned in the reference. Read user guides and how-tos. User guides and how-to articles provide step-by-step instructions on using specific features or solving common problems. These resources often provide practical insights and best practices that can save you time and effort. Refer to them when you need to accomplish a specific task or understand a particular aspect of the technology. Explore community resources. Online communities, such as forums, discussion boards, and Q&A platforms, can be valuable sources of information. Developers often share their experiences, tips, and solutions to common problems in these communities. Participating in discussions and asking questions can help you gain additional insights and perspectives. Take notes and bookmark. As you read through the documentation, take notes of important concepts, code snippets, or examples that you find useful. Create bookmarks or save links to specific sections that you may need to refer back to later. This will help you build a personal knowledge base that you can revisit whenever needed. Experiment and practice. Reading documentation alone is not enough. To truly understand a technology, you need to apply what you learn in practice. Experiment with the code examples, build small projects, and try to solve real-world problems using the technology. This hands-on experience will solidify your understanding and help you internalize the concepts. Remember, documentation is not static and can evolve over time. Stay updated with the latest versions of the documentation and be open to exploring new resources as they become available. By investing time and effort in reading and understanding documentation, you will become a more proficient programmer and be able to leverage the full potential of the tools and technologies you work with. 10.3 Participating in online communities. Participating in online communities is an essential aspect of becoming a better programmer. These communities provide a platform for programmers to connect, collaborate, and learn from each other. By actively engaging in these communities, you can expand your knowledge, gain valuable insights, and enhance your programming skills. In this section, we will explore the benefits of participating in online communities and provide some tips on how to make the most out of your involvement. Benefits of participating in online communities. Participating in online communities offers numerous benefits for programmers. Here are some of the key advantages. 1. Knowledge sharing and learning opportunities. Online communities bring together programmers from diverse backgrounds and skill levels. By actively participating in discussions, asking questions, and sharing your knowledge, you can learn from others and gain valuable insights. These communities often have experts who are willing to help and provide guidance on various programming topics. Additionally, you can also contribute your expertise and help others, which reinforces your own understanding of programming concepts. 2. Networking and collaboration. Online communities provide an excellent platform for networking with other programmers. By connecting with like-minded individuals, you can build professional relationships, collaborate on projects, and even find job opportunities. Engaging in discussions and sharing your work can help you establish a positive reputation within the community, which can open doors for future collaborations and partnerships. 3. Staying updated with the latest trends and technologies. The field of programming is constantly evolving, with new technologies and frameworks emerging regularly. Online communities serve as a valuable source of information for staying updated with the latest trends and technologies. By actively participating in these communities, you can learn about new tools, programming languages, and best practices. This knowledge can help you stay ahead of the curve and make informed decisions when working on projects. 4. Problem solving and troubleshooting. Programming can sometimes be challenging, and you may encounter roadblocks or bugs that are difficult to solve on your own. Online communities provide a platform to seek help and advice from experienced programmers who may have encountered similar issues. By posting your problems and engaging in discussions, you can receive valuable insights, alternative approaches, and potential solutions to overcome obstacles in your programming journey. 5. Building a reputation and personal brand. Active participation in online communities allows you to showcase your skills, knowledge, and expertise. By consistently providing valuable contributions, answering questions, and sharing your work, you can build a positive reputation and establish yourself as an authority in your field. This can lead to opportunities such as speaking engagements, writing guest blog posts, or even job offers from companies who recognize your expertise. Tips for effective participation. To make the most out of your participation in online communities, consider the following tips. 1. Choose the right communities. There are numerous online communities catering to different programming languages, frameworks, and interests. It's important to choose communities that align with your programming goals and interests. Research and explore different platforms such as forums, discussion boards, and social media groups to find communities that have active and engaged members. 2. Be respectful and professional. When participating in online communities, it's crucial to maintain a respectful and professional demeanor. Treat others with kindness and courtesy, even if you disagree with their opinions. Avoid engaging in heated arguments or personal attacks. Remember, online communities are meant to foster a positive and collaborative environment. 3. Contribute meaningfully. Make an effort to contribute meaningfully to discussions. Share your knowledge, insights, and experiences to help others. When asking questions, provide enough context and be specific to receive relevant and helpful responses. Avoid spamming or self-promotion, as it can negatively impact your reputation within the community. 4. Engage regularly. Consistency is key when participating in online communities. Engage regularly by checking in, reading discussions, and contributing whenever possible. By being an active member, you can build relationships, establish your presence, and gain more visibility within the community. 5. Seek help and offer help. Don't hesitate to seek help when you encounter challenges or roadblocks in your programming journey. Online communities are there to support you. However, remember to reciprocate by offering help to others whenever you can. By sharing your knowledge and assisting others, you contribute to the overall growth and development of the community. 6. Follow community guidelines. Each online community has its own set of guidelines and rules. Familiarize yourself with these guidelines and adhere to them. Respect the community's policies regarding posting content, language usage, and appropriate behavior. By following the guidelines, you ensure a positive and harmonious experience for yourself and others. 7. Be open to feedback and constructive criticism. Online communities provide an opportunity to receive feedback and constructive criticism on your work. Embrace feedback with an open mind and use it as an opportunity to improve your skills. Remember, constructive criticism is meant to help you grow as a programmer. Conclusion. Participating in online communities is a valuable way to enhance your programming skills, expand your knowledge, and connect with other programmers. By actively engaging in discussions, sharing your expertise, and seeking help when needed, you can make the most out of your involvement in these communities. Remember to be respectful, contribute meaningfully, and follow community guidelines to create a positive and collaborative environment. Embrace the opportunities that online communities offer and continue to grow as a programmer. 10.4 Attending conferences and workshops. Attending conferences and workshops is an excellent way to enhance your programming skills and stay up to date with the latest trends and technologies in the industry. These events provide opportunities to learn from industry experts, network with fellow programmers, and gain valuable insights into best practices and emerging technologies. In this section, we will explore the benefits of attending conferences and workshops and provide tips on how to make the most out of these events. Benefits of attending conferences and workshops. Attending conferences and workshops can have a significant impact on your professional growth as a programmer. Here are some key benefits. 1. Learning from industry experts. Conferences and workshops often feature renowned speakers and industry experts who share their knowledge and experiences. By attending their sessions, you can gain insights into their expertise, learn about new programming techniques, and discover innovative approaches to problem solving. These experts often provide practical tips and real-world examples that can help you improve your programming skills. 2. Staying updated with the latest trends. The field of programming is constantly evolving, with new technologies and frameworks emerging regularly. Conferences and workshops are an excellent way to stay updated with these trends. You can learn about the latest programming languages, frameworks, tools, and methodologies that are shaping the industry. By staying ahead of the curve, you can ensure that your skills remain relevant and marketable. 3. Networking opportunities. Conferences and workshops bring together programmers from various backgrounds and industries. These events provide an ideal platform to network with like-minded professionals, share ideas, and build connections. Networking can lead to collaborations, job opportunities, and mentorship. By engaging with others in the field, you can gain valuable insights, expand your professional network, and even find potential clients or employers. 4. Discovering new tools and technologies. Conferences and workshops often showcase the latest tools, libraries, and technologies that can enhance your programming workflow. By attending these events, you can explore new tools and technologies firsthand, learn how to integrate them into your projects, and understand their potential benefits and drawbacks. This exposure to new tools can help you streamline your development process and improve your productivity. 5. Gaining inspiration and motivation. Attending conferences and workshops can be highly inspiring and motivating. Listening to success stories, learning about groundbreaking projects, and witnessing the achievements of others in the field can ignite your passion for programming. These events often create an atmosphere of enthusiasm and innovation, which can re-energize your approach to programming and encourage you to push your boundaries. Tips for making the most of conferences and workshops. To maximize your experience at conferences and workshops, consider the following tips. 1. Plan ahead. Before attending a conference or workshop, review the schedule and plan which sessions you want to attend. Identify the topics that align with your interests and goals, and prioritize them. Planning ahead will help you make the most of your time and ensure that you don't miss out on sessions that are most relevant to you. 2. Engage in Q&A sessions and discussions. During sessions, take advantage of the opportunity to ask questions and engage in discussions. This will not only help you clarify any doubts or concerns but also allow you to interact with the speakers and other attendees. Active participation can deepen your understanding of the topics and provide valuable insights from different perspectives. 3. Network with fellow programmers. Make an effort to connect with other attendees during breaks, lunches, or networking events. Strike up conversations, exchange contact information, and follow up with them after the event. Building a strong professional network can open doors to new opportunities, collaborations, and mentorship. 4. Take notes and review them later. During sessions, take notes on key points, ideas, and resources shared by the speakers. These notes will serve as a valuable reference when you revisit the topics later. Reviewing your notes after the event will help reinforce your learning and ensure that you retain the knowledge gained. 5. Explore the exhibition area. Most conferences and workshops have an exhibition area where companies and organizations showcase their products and services. Take the time to explore this area and interact with the exhibitors. You may discover new tools, technologies, or resources that can benefit your programming projects. 6. Share your experience. After attending a conference or workshop, share your experience with your colleagues, peers, or online communities. Write a blog post, give a presentation, or participate in discussions to share the knowledge you gained. By sharing your experience, you not only contribute to the programming community but also reinforce your own learning. Conclusion. Attending conferences and workshops is a valuable investment in your professional development as a programmer. These events provide opportunities to learn from industry experts, stay updated with the latest trends, network with fellow programmers, and gain inspiration and motivation. By planning ahead, actively participating in sessions, networking with others, and sharing your experience, you can make the most out of these events and accelerate your growth as a programmer. So, keep an eye out for upcoming conferences and workshops in your area or consider attending virtual events to expand your knowledge and skills. 11. Working effectively in a team. 11.1 Communication and collaboration skills. Effective communication and collaboration skills are essential for any programmer who wants to excel in their career. As a programmer, you don't work in isolation, you are part of a team that collaborates to build software solutions. Therefore, being able to communicate effectively and work well with others is crucial for success. In this section, we will explore the importance of communication and collaboration skills and provide practical tips to help you improve in these areas. The importance of communication and collaboration skills. Teamwork. Programming is rarely a solo endeavor. Most projects require collaboration with other developers, designers, project managers, and stakeholders. Good communication and collaboration skills enable you to work effectively with others, share ideas, and contribute to the team's success. Understanding requirements. Clear communication is essential for understanding project requirements. By effectively communicating with clients or project managers, you can ensure that you have a thorough understanding of what needs to be built. This helps prevent misunderstandings and reduces the risk of developing the wrong solution. Problem solving. Collaboration often leads to better problem solving. By discussing ideas and sharing perspectives with team members, you can gain new insights and approaches to tackle complex problems. Effective communication allows you to articulate your thoughts and contribute to finding innovative solutions. Reducing errors and misunderstandings. Miscommunication can lead to errors and misunderstandings, which can be costly and time-consuming to fix. By improving your communication skills, you can minimize the chances of misinterpreting requirements, writing incorrect code, or introducing bugs into the system. Building relationships. Strong communication and collaboration skills help you build positive relationships with your team members and stakeholders. When you can effectively communicate your ideas, listen actively, and provide constructive feedback, you create an environment of trust and respect. This fosters better teamwork and enhances the overall productivity and morale of the team. Tips for effective communication and collaboration. Active listening. Listening is a crucial aspect of effective communication. Practice active listening by giving your full attention to the speaker, asking clarifying questions, and summarizing what you've heard. This demonstrates your interest and ensures that you understand the message accurately. Clear and concise communication. When communicating your ideas, be clear and concise. Use simple language, avoid jargon, and organize your thoughts logically. This helps ensure that your message is easily understood by others. Choose the right communication channel. Different situations call for different communication channels. Use email for formal communication, instant messaging for quick questions, and face-to-face or video meetings for complex discussions. Choosing the appropriate channel helps facilitate effective communication. Provide constructive feedback. When providing feedback, focus on the issue at hand and offer suggestions for improvement. Be respectful and considerate of others' feelings. Constructive feedback helps foster a culture of continuous improvement and growth within the team. Collaborate and share ideas. Actively participate in team discussions and brainstorming sessions. Share your ideas and encourage others to do the same. Collaboration allows for the exploration of different perspectives and leads to better solutions. Be open to feedback. Accept feedback from others with an open mind. Constructive criticism helps you grow as a programmer and improve your skills. Avoid becoming defensive and instead use feedback as an opportunity for self-improvement. Document and share knowledge. Document important decisions, project requirements, and technical knowledge to ensure that information is accessible to the entire team. Sharing knowledge promotes transparency and helps team members stay on the same page. Respect deadlines and commitments. Honor your commitments and meet deadlines. Effective communication involves setting clear expectations and delivering on your promises. If you encounter challenges or anticipate delays, communicate them promptly to the relevant stakeholders. Cultural sensitivity. In a diverse team, be mindful of cultural differences and communication styles. Respect and adapt to different perspectives and approaches to foster a harmonious and inclusive work environment. Conflict resolution. Conflicts are inevitable in any team setting. When conflicts arise, address them promptly and professionally. Listen to all parties involved, seek common ground, and work towards a mutually beneficial resolution. Effective conflict resolution strengthens team dynamics and promotes a positive work environment. By continuously improving your communication and collaboration skills, you can enhance your effectiveness as a programmer and contribute to the success of your team and projects. Remember, programming is not just about writing code, it's about working together to create innovative solutions. 11.2. Agile Development and Scrum Methodology. Agile development and Scrum methodology are widely adopted approaches in the software development industry. These methodologies focus on iterative and incremental development, allowing teams to deliver high-quality software in a flexible and collaborative manner. In this section, we will explore the principles and practices of Agile development and Scrum methodology and how they can help you become a better programmer when working in a team. Understanding Agile development. Agile development is an iterative and collaborative approach to software development that emphasizes adaptability and customer satisfaction. It promotes frequent communication, continuous feedback, and the ability to respond to changing requirements. Agile development values individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. One of the key principles of Agile development is the delivery of working software in short iterations called sprints. Each sprint typically lasts for 1 to 4 weeks, during which the team focuses on delivering a set of prioritized features or user stories. At the end of each sprint, the team reviews the work completed and adjusts the project plan based on feedback and changing requirements. Introducing Scrum methodology. Scrum is a popular Agile framework that provides a structured approach to managing and organizing software development projects. It divides the project into a series of time-boxed iterations called sprints, typically lasting 2 to 4 weeks. Scrum teams consist of a product owner, Scrum Master, and development team. The product owner is responsible for defining and prioritizing the product backlog, which is a list of features or user stories that need to be implemented. The Scrum Master facilitates the Scrum process, removes any obstacles that may hinder the team's progress, and ensures adherence to Scrum principles. The development team is responsible for delivering the working software at the end of each sprint. During the sprint planning meeting, the team selects a set of user stories from the product backlog to be implemented in the upcoming sprint. These user stories are broken down into smaller tasks, estimated, and assigned to team members. The team then works on these tasks throughout the sprint, holding daily stand-up meetings to discuss progress, challenges, and plans for the day. At the end of each sprint, the team holds a sprint review meeting to demonstrate the completed work to stakeholders and gather feedback. They also conduct a sprint retrospective to reflect on the process and identify areas for improvement. The insights gained from the retrospective are used to refine the project plan and backlog for the next sprint. Benefits of Agile development and Scrum methodology. Adopting Agile development and Scrum methodology can bring several benefits to both individual programmers and the team as a whole. Flexibility and adaptability. Agile development allows teams to respond quickly to changing requirements and priorities. It promotes a flexible mindset and encourages continuous improvement throughout the project. Collaboration and communication. Agile development emphasizes frequent communication and collaboration among team members. This leads to better understanding, shared knowledge, and improved problem-solving capabilities. Transparency and visibility. Scrum provides a transparent and visible framework for managing projects. The use of visual boards, such as Scrum boards or Kanban boards, allows team members to track progress, identify bottlenecks, and ensure everyone is on the same page. Early and continuous feedback. Agile development encourages regular feedback from stakeholders, allowing for early identification of issues and the ability to make necessary adjustments. This iterative feedback loop helps ensure that the final product meets the customer's expectations. Increased productivity. By breaking down work into smaller, manageable tasks and focusing on delivering value in short iterations, Agile development promotes productivity and reduces the risk of project delays. Improved quality. Agile development emphasizes the delivery of working software at the end of each sprint. This iterative approach allows for continuous testing, bug fixing, and quality assurance, resulting in a higher quality end product. Motivated and empowered teams. Agile development promotes self-organizing teams that have the autonomy to make decisions and take ownership of their work. This empowerment leads to increased motivation, job satisfaction, and overall team performance. Tips for being an effective Agile team member. To be a better programmer in an Agile team, consider the following tips. Embrace collaboration. Actively participate in team discussions, share your ideas, and collaborate with others to find the best solutions. Foster a culture of open communication and respect for diverse perspectives. Be adaptable, embrace change and be willing to adjust your plans and priorities as new information emerges. Agile development requires flexibility and adaptability to deliver the best possible outcome. Take ownership, take responsibility for your work and strive for excellence. Be proactive in identifying and resolving issues, and continuously seek opportunities for improvement. Communicate effectively. Clearly communicate your progress, challenges, and needs to the team. Actively listen to others and provide constructive feedback. Effective communication is crucial for successful collaboration. Practice time management. Prioritize your tasks and manage your time effectively to meet sprint goals. Break down complex tasks into smaller, manageable ones, and regularly reassess your progress. Embrace continuous learning. Agile development encourages continuous learning and improvement. Stay updated with the latest industry trends, technologies, and best practices to enhance your skills and contribute to the team's success. Support the team. Offer assistance to your teammates when needed and be willing to share your knowledge and expertise. A supportive and collaborative team environment leads to better outcomes. By adopting Agile development and Scrum methodology, you can enhance your programming skills, improve collaboration, and deliver high-quality software in a more efficient and effective manner. Embrace the principles and practices of Agile development, and strive to be an active and valuable member of your Agile team. 11.3. Task management and prioritization. As a programmer, you often find yourself juggling multiple tasks and projects simultaneously. Effective task management and prioritization are crucial skills that can help you stay organized, meet deadlines, and deliver high-quality work. In this section, we will explore some strategies and techniques to help you manage your tasks efficiently and prioritize them effectively. 1. Understand the requirements. Before you start working on any task, it is essential to have a clear understanding of the requirements. Take the time to review the project specifications, user stories, or any other relevant documentation. If you have any doubts or uncertainties, seek clarification from your team or project manager. By having a thorough understanding of the task at hand, you can better plan and prioritize your work. 2. Break down tasks. Large tasks can often feel overwhelming and lead to procrastination. To avoid this, break down your tasks into smaller, manageable subtasks. This approach not only makes the work more approachable but also allows you to track progress more effectively. Use task management tools or project management software to create a task hierarchy and assign deadlines to each subtask. Breaking down tasks also helps you identify dependencies and prioritize accordingly. 3. Prioritize based on importance and urgency. Not all tasks are created equal. Some tasks may be more critical or time-sensitive than others. To prioritize effectively, consider both the importance and urgency of each task. Importance refers to the impact a task has on the overall project or business goals. Urgency, on the other hand, relates to the time sensitivity of a task. By evaluating tasks based on these factors, you can allocate your time and resources more efficiently. One popular method for prioritization is the Eisenhower matrix, which categorizes tasks into 4 quadrants. Urgent and important. These tasks require immediate attention and should be your top priority. Important but not urgent. These tasks are significant but can be scheduled for later. Urgent but not important. These tasks may require your attention, but they can often be delegated or automated. Not urgent and not important. These tasks are low priority and can be eliminated or postponed. By using the Eisenhower matrix or a similar prioritization framework, you can make informed decisions about which tasks to tackle first. 4. Estimate time and effort. Accurately estimating the time and effort required for each task is crucial for effective task management. Break down your tasks into smaller units and estimate the time needed for each unit. Consider any dependencies, potential roadblocks, or additional research required. It is better to overestimate than underestimate, as unexpected challenges can arise during the development process. By having realistic estimates, you can plan your workload and deadlines more effectively. 5. Use task management tools. Task management tools can be invaluable for organizing and tracking your tasks. There are numerous options available, ranging from simple to-do list apps to comprehensive project management software. Find a tool that suits your needs and preferences. Some popular task management tools include Trello, Asana, Jira, and Microsoft Planner. These tools allow you to create tasks, set deadlines, assign priorities, and collaborate with your team. Utilizing such tools can help you stay organized, visualize your workload, and ensure that nothing falls through the cracks. 6. Practice time blocking. Time blocking is a technique where you allocate specific time blocks for different tasks or activities. By dedicating focused time to specific tasks, you can minimize distractions and increase productivity. Start by identifying your most productive hours and schedule your most important or challenging tasks during that time. Be realistic about the time required for each task and allocate buffer time for unexpected interruptions or delays. During your scheduled time blocks, eliminate distractions, such as turning off notifications or finding a quiet workspace. Time blocking can help you maintain a structured workflow and ensure that you make progress on your tasks consistently. 7. Communicate and collaborate. Effective task management is not just about individual effort, it also involves effective communication and collaboration with your team. Regularly communicate with your team members, project manager, or stakeholders to provide updates on your progress, discuss any challenges, and seek assistance if needed. Collaborate with your team to identify dependencies, resolve conflicts, and ensure that everyone is aligned with the project goals. By fostering open communication and collaboration, you can streamline task management and ensure the successful completion of projects. 8. Regularly review and adjust. Task management is an iterative process. It is essential to regularly review your tasks, priorities, and progress. Take the time to evaluate your task management strategies and identify areas for improvement. Are there any tasks that can be delegated or automated? Are there any bottlenecks or inefficiencies in your workflow? By reflecting on your task management practices, you can make adjustments and optimize your productivity. In conclusion, effective task management and prioritization are essential skills for any programmer. By understanding the requirements, breaking down tasks, prioritizing based on importance and urgency, estimating time and effort, using task management tools, practicing time blocking, communicating and collaborating with your team, and regularly reviewing and adjusting your approach, you can enhance your productivity and deliver high-quality work consistently. 11.4 Resolving conflicts and handling feedback. As a programmer, you will inevitably encounter conflicts and receive feedback throughout your career. Resolving conflicts and handling feedback effectively is crucial for maintaining a positive and productive work environment. In this section, we will explore strategies and techniques to help you navigate conflicts and feedback in a professional manner. Understanding conflict resolution. Conflict can arise in various situations, such as differences in opinions, conflicting priorities, or misunderstandings. It is important to approach conflicts with a mindset of finding a resolution rather than escalating the situation. Here are some steps you can take to effectively resolve conflicts. Identify the issue, clearly define the problem or disagreement at hand. Take the time to understand the perspectives of all parties involved. Active listening. Practice active listening by giving your full attention to the other person's point of view. Avoid interrupting or dismissing their opinions. This will help foster open communication and build trust. Seek common ground. Look for areas of agreement or shared goals. Finding common ground can help bridge the gap between conflicting parties and create a foundation for resolving the conflict. Explore alternative solutions. Brainstorm potential solutions together. Encourage everyone involved to contribute ideas and consider different perspectives. This collaborative approach can lead to creative solutions that satisfy all parties. Evaluate and choose the best solution. Assess the proposed solutions based on their feasibility, impact, and alignment with the project or team goals. Select the solution that best addresses the conflict and benefits the overall outcome. Implement and follow up. Once a solution is agreed upon, ensure that it is implemented effectively. Monitor the situation and follow up to ensure that the conflict has been resolved satisfactorily. Handling feedback. Feedback is an essential part of personal and professional growth. It provides valuable insights into your work and helps you identify areas for improvement. Here are some tips for handling feedback effectively. Be open-minded. Approach feedback with an open mind and a willingness to learn. Remember that feedback is not a personal attack but an opportunity for growth. Listen actively. When receiving feedback, listen attentively and avoid becoming defensive. Allow the person providing feedback to express their thoughts fully before responding. This demonstrates respect and shows that you value their input. Ask for clarification. If the feedback is unclear or you need more information, don't hesitate to ask for clarification. Seek specific examples or suggestions for improvement to better understand the feedback. Reflect and evaluate. Take time to reflect on the feedback and evaluate its validity. Consider the source of the feedback, their expertise, and the context in which it was given. Use this evaluation to determine the relevance and importance of the feedback. Take action. Once you have processed the feedback, develop an action plan to address the areas for improvement. Set specific goals and timelines to track your progress. Taking action demonstrates your commitment to growth and development. Express gratitude. Show appreciation to those who provide feedback, regardless of whether it was positive or constructive. Expressing gratitude fosters a positive feedback culture and encourages others to continue providing valuable input. Dealing with difficult feedback. Not all feedback will be easy to receive. Sometimes, you may encounter feedback that feels harsh or unfair. In such situations, it is important to maintain professionalism and handle the feedback constructively. Here are some strategies for dealing with difficult feedback. Stay calm. Take a deep breath and remain calm when receiving difficult feedback. Avoid reacting impulsively or defensively. Remember that emotions can cloud your judgment and hinder productive communication. Seek clarification. If the feedback is unclear or seems unjustified, ask for specific examples or further explanation. This can help you gain a better understanding of the feedback and address any misunderstandings. Consider the source. Evaluate the credibility and intentions of the person providing the feedback. Not all feedback may be valid or relevant. Consider the expertise and experience of the person giving the feedback before internalizing it. Focus on improvement. Instead of dwelling on the negative aspects of the feedback, shift your focus to how you can use it to improve. Look for opportunities to grow and develop based on the feedback received. Discuss with a mentor or trusted colleague. If you are struggling to process difficult feedback, seek guidance from a mentor or a trusted colleague. They can provide an objective perspective and help you navigate the situation effectively. Learn from the experience. Every feedback, even difficult ones, can be a learning opportunity. Use the experience to develop resilience, improve your skills, and enhance your ability to handle challenging situations in the future. Remember, conflicts and feedback are part of professional life. By approaching conflicts with a resolution-oriented mindset and handling feedback constructively, you can foster a positive work environment and continuously improve as a programmer. 12. Career growth and advancement. 12.1 Building a professional portfolio. A professional portfolio is an essential tool for any programmer looking to advance their career and showcase their skills and accomplishments. It serves as a visual representation of your work and allows potential employers or clients to assess your abilities and expertise. Building a professional portfolio requires careful planning and attention to detail. In this section, we will explore the key elements of a successful portfolio and provide guidance on how to create an impressive and effective showcase of your programming skills. Why is a professional portfolio important? A professional portfolio is more than just a collection of your work. It is a reflection of your professionalism, creativity, and dedication to your craft. Here are a few reasons why having a well-crafted portfolio is crucial for your career growth. Demonstrates your skills and expertise. A portfolio allows you to showcase your programming skills and demonstrate your ability to solve real-world problems. It provides tangible evidence of your capabilities and helps potential employers or clients assess your suitability for a particular role or project. Sets you apart from the competition. In a competitive job market, having a portfolio can give you a significant advantage over other candidates. It shows that you are proactive, committed to your profession, and willing to go the extra mile to showcase your work. Builds credibility and trust. A well-designed portfolio can help establish your credibility as a programmer. It allows others to see the quality of your work and builds trust in your abilities. This can be particularly valuable when seeking freelance opportunities or working with clients who may not have prior experience with your work. Provides a platform for self-reflection and improvement. Creating a portfolio requires you to review and evaluate your past projects. This process allows you to identify areas for improvement and refine your skills. It also provides an opportunity to showcase your growth as a programmer over time. Key elements of a professional portfolio. To create an effective professional portfolio, consider including the following key elements. 1. Introduction and about me. Start your portfolio with a brief introduction that highlights your background, experience, and areas of expertise. This section should provide a concise overview of who you are as a programmer and what sets you apart from others in your field. Consider including a professional headshot and a short bio to personalize your portfolio. 2. Projects and case studies. The centerpiece of your portfolio should be a showcase of your projects and case studies. Select a range of projects that highlight your skills and demonstrate your ability to solve complex problems. Include a brief description of each project, outlining the problem you were trying to solve, the technologies used, and the outcome or impact of the project. Whenever possible, include screenshots or snippets of code to provide a visual representation of your work. 3. Skills and technologies. Create a section that highlights your technical skills and the programming languages, frameworks, and tools you are proficient in. This section should provide a comprehensive overview of your technical expertise and help potential employers or clients assess your suitability for specific projects or roles. 4. Education and certifications. Include a section that outlines your educational background, including any relevant degrees or certifications you have obtained. This section helps establish your qualifications and demonstrates your commitment to continuous learning and professional development. 5. Testimonials and recommendations. Consider including testimonials or recommendations from previous clients, colleagues, or employers. These endorsements can provide valuable social proof and help build trust in your abilities. Reach out to individuals who can vouch for your skills and request a short testimonial that highlights your strengths and contributions. 6. Contact information and social media links. Make it easy for potential employers or clients to get in touch with you by including your contact information, such as your email address and phone number. Additionally, consider including links to your professional social media profiles, such as LinkedIn or GitHub, where interested parties can learn more about your work and connect with you. Tips for creating an impressive portfolio. Here are some tips to help you create an impressive and effective professional portfolio. Curate your projects. Select a diverse range of projects that showcase your skills and expertise. Choose projects that demonstrate your ability to solve different types of problems and highlight your versatility as a programmer. Focus on quality over quantity. It's better to showcase a few high-quality projects than to include a large number of mediocre ones. Select projects that you are proud of and that best represent your abilities. Keep it organized and visually appealing. Design your portfolio in a clean and organized manner. Use a consistent layout, typography, and color scheme to create a visually appealing and professional-looking portfolio. Update regularly. Keep your portfolio up to date by adding new projects and removing outdated ones. Regularly review and refine your portfolio to ensure it accurately reflects your current skills and accomplishments. Seek feedback. Ask for feedback from peers, mentors, or industry professionals to get an outside perspective on your portfolio. Incorporate their suggestions to improve the overall quality and effectiveness of your portfolio. Promote your portfolio. Share your portfolio with your network and promote it on professional platforms such as LinkedIn or relevant online communities. Actively seek opportunities to showcase your work and direct potential employers or clients to your portfolio. Remember, your professional portfolio is a living document that should evolve as you grow and gain new experiences. Continuously update and refine your portfolio to reflect your latest achievements and skills. By investing time and effort into building a professional portfolio, you can enhance your career prospects and position yourself as a standout programmer in the industry. 12.2. Networking and building connections. Networking and building connections are essential aspects of career growth and advancement for programmers. In today's interconnected world, having a strong professional network can open up numerous opportunities for collaboration, learning, and career advancement. This section will provide you with valuable insights and strategies on how to effectively network and build connections within the programming community. The importance of networking. Networking is not just about collecting business cards or adding connections on social media platforms. It is about building meaningful relationships with like-minded professionals who can support and guide you throughout your career. Here are some key reasons why networking is crucial for programmers. Opportunities for collaboration. Networking allows you to connect with other programmers, developers, and industry experts who may have complementary skills or knowledge. Collaborating with these individuals can lead to the creation of innovative projects and solutions. Knowledge sharing. Networking provides a platform for sharing knowledge, experiences, and best practices. By engaging in conversations with other professionals, you can gain valuable insights, learn new techniques, and stay updated with the latest trends and technologies. Career advancement. Building a strong network can open doors to new job opportunities, promotions, and career growth. Many job openings are filled through referrals and recommendations, and having a network of professionals who can vouch for your skills and expertise can significantly enhance your chances of success. Mentorship and guidance. Networking allows you to connect with experienced professionals who can serve as mentors and provide guidance throughout your career journey. These mentors can offer valuable advice, share their experiences, and help you navigate challenges and make informed decisions. Strategies for effective networking. Now that you understand the importance of networking, let's explore some strategies to help you build and maintain strong connections within the programming community. 1. Attend industry events and meetups. Industry events, conferences, and meetups provide excellent opportunities to network with professionals from various backgrounds. Make an effort to attend relevant events in your area or consider participating in virtual conferences. Engage in conversations, ask questions, and exchange contact information with individuals who share similar interests or work in your desired field. 2. Join online communities and forums. Online communities and forums dedicated to programming and software development are great platforms for networking. Participate actively in discussions, share your knowledge, and seek advice from experienced professionals. Platforms like Stack Overflow, GitHub, and Reddit have vibrant communities where you can connect with programmers worldwide. 3. Utilize social media platforms. Social media platforms like LinkedIn, Twitter, and GitHub can be powerful tools for networking. Create a professional profile, share your work, and engage with other professionals in your field. Follow influential programmers, join relevant groups, and contribute to discussions to expand your network. 4. Contribute to open source projects. Contributing to open source projects not only allows you to enhance your programming skills but also provides an opportunity to connect with other developers. Engage in discussions, collaborate on projects, and build relationships with individuals who share your passion for open source software. 5. Attend workshops and training programs. Participating in workshops and training programs related to programming can help you meet professionals who are actively seeking to expand their knowledge. These events often provide networking opportunities during breaks and networking sessions. Take advantage of these moments to connect with fellow participants and industry experts. 6. Seek mentorship. Identify experienced professionals in your field who can serve as mentors. Reach out to them, express your admiration for their work, and ask if they would be willing to provide guidance. Having a mentor can significantly accelerate your learning and career growth. 7. Be genuine and helpful. When networking, it is essential to be genuine and approachable. Show a genuine interest in others' work, listen actively, and offer help whenever possible. Building authentic relationships based on mutual respect and support will lead to long-lasting connections. 8. Follow up and stay connected. After networking events or initial conversations, make sure to follow up with the individuals you connected with. Send a personalized message expressing your appreciation for the conversation and expressing your interest in staying connected. Regularly engage with your network by sharing relevant articles, projects, or opportunities. Conclusion. Networking and building connections are vital for career growth and advancement in the programming industry. By actively engaging in networking activities, attending industry events, joining online communities, and seeking mentorship, you can expand your professional network and open doors to new opportunities. Remember to be genuine, helpful, and proactive in maintaining connections with your network. Building strong relationships within the programming community will not only enhance your skills but also provide support and guidance throughout your career journey. To become a better programmer, there are several key areas you can focus on. These include improving your technical skills, enhancing your problem-solving abilities, and developing effective communication and collaboration skills. Additionally, staying up to date with industry trends and continuously learning and improving are essential for career growth. Let's explore these areas in more detail. Technical skills. Master the fundamentals. Ensure you have a strong foundation in programming concepts, data structures, algorithms, and design patterns. This will help you approach problems with a solid understanding of the underlying principles. Learn multiple programming languages. Familiarize yourself with different programming languages to broaden your skill set and adapt to various project requirements. Practice regularly. Dedicate time to coding exercises, challenges, and personal projects to reinforce your skills and explore new concepts. Stay updated. Keep up with the latest technologies, frameworks, and tools in your field. This will help you stay relevant and make informed decisions when choosing the right tools for your projects. Problem-solving abilities. Analyze and break down problems. Develop the ability to break down complex problems into smaller, more manageable tasks. This will make problem-solving more approachable and help you identify the most efficient solutions. Algorithm design and optimization. Learn different algorithmic techniques and strategies to solve problems more efficiently. Understand time and space complexity to evaluate the performance of your solutions. Debugging and troubleshooting. Sharpen your debugging skills to identify and fix issues in your code effectively. Learn to use debugging tools and techniques to streamline the process. Communication and collaboration skills. Effective communication. Learn to communicate clearly and concisely, both verbally and in writing. This includes explaining technical concepts to non-technical stakeholders and collaborating effectively with team members. Active listening. Practice active listening to understand requirements, feedback, and concerns from clients, colleagues, and users. This will help you build better solutions and foster positive working relationships. Collaboration and teamwork. Develop the ability to work well in a team environment. This includes being open to feedback, contributing ideas, and respecting diverse perspectives. Embrace agile methodologies like Scrum to enhance collaboration and productivity. Continuous learning and improvement. Stay curious, cultivate a growth mindset and a passion for learning. Embrace new technologies, frameworks, and methodologies to expand your knowledge and stay ahead in the industry. Read documentation. Develop the skill of reading and understanding technical documentation. This will help you effectively utilize APIs, libraries, and frameworks in your projects. Participate in online communities. Engage with online programming communities, forums, and social media groups. Share your knowledge, ask questions, and learn from others' experiences. Attend conferences and workshops. Take advantage of industry conferences, workshops, and meetups to network with professionals, learn from experts, and stay updated with the latest trends. By focusing on these areas, you can continuously improve your programming skills, problem-solving abilities, and overall effectiveness as a programmer. Remember, becoming a better programmer is a journey that requires dedication, practice, and a commitment to lifelong learning. 12.4. Continuing education and certifications. As a programmer, it is essential to continuously learn and grow in order to stay relevant in the ever-evolving field of technology. Continuing education and certifications play a crucial role in enhancing your skills, expanding your knowledge, and demonstrating your expertise to potential employers. In this section, we will explore the importance of continuing education and certifications for programmers and provide guidance on how to make the most of these opportunities. The importance of continuing education. Technology is constantly advancing, and new programming languages, frameworks, and tools are being introduced regularly. To stay competitive in the job market and maintain your edge as a programmer, it is crucial to keep up with the latest trends and developments. Continuing education allows you to stay current with industry standards, learn new techniques, and acquire new skills that can enhance your productivity and effectiveness as a programmer. Continuing education also provides an opportunity to deepen your understanding of fundamental programming concepts and explore advanced topics. By investing time in learning new technologies and expanding your knowledge base, you can become a more versatile and well-rounded programmer. This can open doors to new career opportunities and increase your earning potential. Choosing the right continuing education options. When it comes to continuing education, there are numerous options available, ranging from online courses and tutorials to workshops, bootcamps, and formal degree programs. The key is to choose the options that align with your learning style, goals, and schedule. Here are a few popular options to consider. Online courses and tutorials. Online platforms such as Coursera, Udemy, and Pluralsight offer a wide range of programming courses and tutorials. These platforms provide flexibility in terms of timing and allow you to learn at your own pace. Look for courses that are taught by industry experts and have good reviews. Focus on topics that are relevant to your current or desired area of expertise. Workshops and bootcamps. Workshops and bootcamps are intensive, short-term programs that focus on specific programming languages or technologies. These programs often provide hands-on experience and allow you to learn from experienced instructors. They can be a great way to quickly gain practical skills and network with other professionals in the field. Formal degree programs. If you are looking for a more comprehensive and structured approach to continuing education, pursuing a formal degree program in computer science or a related field can be a valuable option. A degree program provides a deep understanding of programming principles, algorithms, and software engineering concepts. It can also open doors to research and academic positions. Certifications for programmers. Certifications are a way to validate your skills and knowledge in a specific programming language, technology, or methodology. They can enhance your credibility and demonstrate your commitment to professional growth. Here are some popular certifications for programmers. Microsoft Certified, Azure Developer Associate. This certification validates your expertise in developing applications using Microsoft Azure. It demonstrates your ability to design, build, test, and maintain cloud-based applications using Azure services and tools. Oz Certified Developer, Associate. This certification is designed for developers who have experience in designing and maintaining applications on the Amazon Web Services Oz platform. It validates your ability to develop, deploy, and debug cloud-based applications using AWS services. Oracle Certified Professional, Java SE Programmer. This certification is for Java programmers who want to demonstrate their proficiency in Java programming language and related technologies. It covers topics such as Java syntax, object-oriented programming, and database connectivity. Certified Scrum Developer, CSD. The CSD certification is for software developers who work in Agile environments using Scrum methodology. It validates your understanding of Agile principles, Scrum framework, and your ability to work effectively as part of an Agile team. Google Certified Professional, Data Engineer. This certification is for professionals who work with data and want to demonstrate their expertise in designing, building, and maintaining data processing systems on the Google Cloud Platform. It covers topics such as data modeling, data ingestion, and data transformation. Making the most of continuing education and certifications. To make the most of your continuing education and certification efforts, consider the following tips. Set clear goals. Before embarking on any learning journey, it is important to set clear goals. Identify the skills or knowledge you want to acquire and how they align with your career aspirations. This will help you choose the right courses or certifications that will bring you closer to your goals. Create a learning plan. Develop a learning plan that outlines the courses or certifications you want to pursue, the resources you will need, and a timeline for completion. Breaking down your learning goals into smaller, manageable tasks can help you stay focused and motivated. Practice hands-on coding. Theory alone is not enough to become a proficient programmer. Make sure to practice what you learn by working on coding exercises, personal projects, or contributing to open-source projects. Hands-on experience will reinforce your understanding and help you apply your knowledge in real-world scenarios. Network and collaborate. Engage with other programmers and professionals in the field through online communities, forums, and social media platforms. Networking can provide valuable insights, mentorship opportunities, and potential collaborations. It can also help you stay updated on industry trends and job opportunities. Stay curious and keep learning. Continuing education is a lifelong journey. Stay curious and keep learning even after obtaining certifications or completing courses. Technology is constantly evolving, and staying ahead requires a commitment to continuous learning and improvement. Conclusion. Continuing education and certifications are essential for programmers who want to stay competitive and advance in their careers. By investing in your professional development, you can expand your knowledge, acquire new skills, and demonstrate your expertise to potential employers. Choose the right continuing education options, set clear goals, and stay committed to lifelong learning. Remember, the journey to becoming a better programmer is a continuous one.